Hey everyone, and welcome to episode 1 of this brand new series, R Programming for Absolute Beginners. And today's episode is going to be an introduction to R as well as a guide to set things up on your device. And this course is going to be really simple and easy paced course. So if you have never written a line of code before, this course is exactly for you. Alright, so to begin with, let's ask ourselves this question: what is R? Well, R is a programming language, but not just any programming language. R was built specifically for working with data, doing statistics, analyzing information, and also making charts and visualizations with the help of data. So yes, R is very data specific, and it shines the moment you start working with numbers, tables, spreadsheets, or anything real world related. But here's the important part when you're starting to learn R. You don't need to know statistics, you don't need to know programming, and you don't need to be smart at math to start with the basics. So, like I said, we're starting from the basics, that is variables, data types, functions, and the essential fundamentals that every beginner needs. And we will slowly build towards real world data work later. Now when starting to work with R, a question might pop up into your mind. Is R important? I have never really heard of it before. So let's discuss just that. So why is R still such a big deal today? Why does R matter? Well, because nowadays almost every field is drowning in data, and R makes help sense of that data. Whether you're a student, a researcher, a business person, or just curious, R gives you the power to clean messy information, understand patterns that are hidden in data, make graphs from that data that tell a story, run meaningful calculations, and also solve real-world problems, and all with a language that's beginner-friendly once you know the basics. And now that I've mentioned the word beginner-friendly, a question might arise. If R is built so specifically for data, can a complete beginner learn it? And the answer to that question is yes. And in fact, R is one of the best places to start. And here's why. Why R is good for beginners? Well, one of the reasons is R reads almost like English. There are commands like mean, numbers, or summary data, where numbers are a group of, numbers, and data is a group of numbers as well. These commands literally describe what they do. This calculates the mean, and this tells you the summary of the given data. Next, you get instant feedback. You type something into the R compiler or the R script, and R prints the results immediately. You understand what happened, and it's a great learning loop. Next, RStudio. RStudio makes everything easier. RStudio is the editor that we'll be using, which gives you buttons, panels, tabs, and help menus that make learning less overwhelming. And the next and final reason as to why R is good for beginners is inside R, you don't need to build big apps or complicated programs. You can start with simple tasks and scale your way up. You can start with tasks such as storing values inside variables, doing calculations, making small functions, and manipulating small datasets and visualizing that dataset or that data with the help of charts. So, now, let's discuss what this series will actually cover. Designed for people starting from zero. What will this series teach you? First of all, this series will teach you core programming basics. Concepts such as what variables are, data types, vectors, lists, and data frames, basic maths and operations, conditional statements like if and else, loops, and writing your own simple functions. These are the core programming basics that we'll be discussing throughout this course. And not just core programming basics, it will teach you, of course, essential R concepts as well. Concepts such as the R console, the script editor, how R reads data, how to install and load packages, how to use RStudio effectively, working with simple datasets, and making your very first simple plots. Nothing overwhelming and nothing too advanced. Just the foundations, explained clearly, slowly, and with real-world examples. And now that we have discussed about what this series will teach you, let's talk about what this series is not, or let's say what we are saving for later. To be super clear, this is not the R for Data Science course. That one is a separate series that we'll be releasing later. It'll go deeper into concepts such as data cleaning, analysis, data visualization, and working with libraries such as ggplot2. This series is all about building fundamentals so that when you do reach the data science level, it feels natural and easy. So, finally, let's discuss about what we need to do before we begin working with R. before we start working with R, you need to make sure you have R installed, R Studio installed, and a bit of curiosity, and nothing else. So first of all, let's start with installing R, shall we? And before we move on with the video, a quick shout out to the R Programming Learn and Code app from Codin inside the Google Play Store. With this app, you can learn R right from your phone anytime and anywhere. And there are engaging and interactive courses on the app that make learning fun. And with quick facts and quizzes inside each course, you'll be truly understanding R and not just memorizing it. It also has an R compiler which allows you to type and test any bits of R code that you want. So, if you want to learn R and are looking for somewhere to start, do check out the R Programming app from Codin inside the Google Play Store. Now let's move on with the video. So what you need to do to install R on your device is first you have to open your browser. I'll be opening a new tab, and then you have to head over to cran.r-project.org. So after that, you'll be directed to this web page right here where you are prompted with the download options for both Mac and Windows and also Linux. So you can choose a download option according to your operating system. I'm using Windows, so I'll be selecting download R for Windows, and then you'll be directed to this web page. And among the subdirectories, you have to go over to base. And here is the download file for Windows. Now R 4.5.2 is the latest version as of November 20, 2025, the time that I'm recording this video. So I'll click on this, and since I've already downloaded the exe file, it'll prompt me with this window, and this is the exe file for R. Now if I execute this, it'll prompt me with a setup. So you have to click on yes. After that, it will prompt you to select the language, and after that the installation is simple. You have to keep clicking next until it's done. So no special configuration is needed. So okay, and then okay, I'll just pretend that I've read this, and then next, and then next. This is the directory. None of the things have to be changed. Next, 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 and then next. So this will install R on your device. So I'll cut to where this is completed. Okay, so after the setup completes, you can click on finish, and now you have successfully installed R on your device. Now R by itself works, but we will be using R Studio as well, as mentioned before, to make things easier and organized for us. So as you can see, I've already downloaded the setup file for R Studio as well, but I'll show you guys how to download it. So after you have downloaded R, you can just open your browser once again and go to posit.co/download/rstudio-desktop. So I'll be leaving these links down in the description, so you don't have to worry about that. After you head over to this web page right here, it'll prompt you to download R. Now since we have installed R on our device already, you don't have to do this, but instead you have to click on download R Studio Desktop for Windows. After you click this, it will prompt you with installation of the setup file, and since I have already downloaded this setup file as well, I'll be clicking on OK and opening my folder. So after you have downloaded your setup file, you can click on this to execute the installation. Click on yes, and then you will be prompted with the setup window for this as well. Now after you have clicked on the exe file, you can just keep on clicking next and install it like any other app. So next, and then it starts installing. Okay, so once the setup is completed, R Studio has already been installed on your computer. So you can head over and click on to finish, and then go to search and then type R Studio. You can click on enter and it will open R Studio for you. So this is where we will be spending most of our time working with R. Now when you open R Studio, you'll be seeing 4 main panels. And if you don't see the main panel at first, you can just, I think you'll be, when you install R Studio on your device at first, you'll be prompted with this. And you don't have to worry if you don't see 4 panels. You can just head over to File, and then New File, and then R Script. So this will open a new file, or let's say a new R script for you, and then you will have 4 panels. So first is the bottom left panel, that is our console. This is the heart of R, and anything you type here runs immediately. We can see the output of our code over here, or we can just write our expressions like 1 + 1 and then see our answer right here. So this is the console. And then on our top left panel, we have the script, or let's say the editor. So this is where you write code that you want to save and execute. And think of it like a notebook that you use to find out the results of your data, or let's say the results of your code. And then on the top right, we have our environment and history panel, where you'll be able to see the history of your commands. These are the commands that I executed previous, or let's say prior to recording this video, and the commands that I'll be explaining to you guys today. And this is the environment, where you can see the variables that you have created and what values are held by those variables. And you can also see the data that you are currently working with. And after this, we have the bottom right panel, that is the files, plots, packages, and help. So here in this panel, you'll find your files, and if you are working with graphs, you'll be able to see your plots as well, and then installed libraries that are packages, and also documentation as well. So after we have discussed about the environment of R, I'll increase the font size for you guys. Let's run our very first R command. So after running 1 plus 1, let's do 2 minus 1, and let's see the answer. It's 1. So it is just that simple. This is how R works. You type something, and then it immediately shows the result after you press enter. And you can also think of R as a really sophisticated calculator, since it helps us to do really massive calculations. But we'll not be dealing with that today. We'll be discussing it further in the future. Now, let's write real code in a script. After you have created our R script by doing file, new file, and then R script, you can start with writing your code. Now, let's first of all add two variables. Let's say I do X, and if I want to store a value in this variable, I just have to make an arrow symbol. So I do this by using the less than, or let's say lesser than symbol, and then a hyphen. And after that, let's say I want to store the value of 10 in our X, or let's say 20. So this stores the value of 20 in X, and if you do Control and Enter, you can see it in the console that it is saved as 20. And if you look over to our environment panel as well, you can see the value of X is stored as 20. Now let's create a Y variable by clicking on our file, and then Y, an arrow symbol, and let's say it has a value of 30. So if I do Control Enter, it will save our value as 30. So Y is 30, as you can see in our environment tab, or let's say panel. Now in order to run a calculation, we'll do X plus Y, and if I hit Control Enter, in the console you'll be able to see that X plus Y's value, that is 50, is outputted. So this is how you perform calculations inside R. To run a line, you can place your cursor on that line and then hit Control Enter in Windows and Linux, or Command Enter in Mac. So do keep in mind that RStudio only keeps track of variables that you have executed on the console, or let's say executed in the current session. So if I were to create two variables called A and B, so let's say A is 5 and then B is 6, and I try to do A plus B. Now keep in mind that I have not executed these variables with Control plus Enter. If I click on A plus B line and do Control Enter, you'll be able to see that it says object A not found. And if you look at our environment panel as well, you'll be able to see that A is not recorded. So do keep in mind that you have to first of all execute these in the session. So if I select all of this and do Control Enter, you'll finally be able to see that A and B are recorded on our environment variables, or let's say environment values, and A and B are recorded on our console as well. Now when I finally do A plus B and hit Control plus Enter, you'll be able to see that it computes. So RStudio sends this line to the console and prints the results. Now before we move on, let's understand a few essentials. First of all, there are variables, which we will be discussing in our next episode in detail. So first, you can think of it as storing values. X has stored the value of 20, Y has stored the value of 30, and so on with A and B. And next, you can also do basic maths with the help of R. So let's say I wanted to calculate 5 to the power of 20. So 5 to the power of 20. It's hard to calculate without a calculator. Now, like I said before, R is basically a sophisticated calculator. So you can just hit Control and Enter, and it'll output you with the value. So that's a really big number. So I'll just do 5 to the power of, let's say, 6. And Enter. You can see it outputs the value. So you can do basic maths with the help of R as well. And then you have the option to execute functions. Now let's say I wanted to find the square root of 16. So you could just do sqrt. This is a function inside R, and then hit 16. Now if I do Control Enter, you can see that the square root of 16 is 4. And there are other functions as well. You can also calculate the mean of values. So let's say I have a collection of values. Let's say I have numbers, and inside this numbers variable, I'll be storing a collection of values. So let's say C, and then 1, 2, 3, 4, and then 5. And do Control Enter. You can see that it has stored the collection of 1, 2, 3, 4, 5. And then after that, if you want to find out the mean of this collection, you can just do mean and then numbers to find out the mean. So Control Enter, and you can see that the mean is 3, which will be correct. So when you use this C and then group a bunch of numbers together, this just means combine. You're basically grouping a bunch of numbers together into one container, and R calls this container a vector. But you don't need to worry about that word at first. Just think of it as a list of values that we want to store together inside a variable called numbers. So this is how R works. If you want to save your code so that you can reuse it later, you can just hit Control and S, and then it will prompt you with saving a code. So let's say I store it as first R file, and then it saves it. So like I said before, you can visualize your data with the help of R as well. So before we end our episode, let's see a tiny graph. So if I do plot and then enter our collection of numbers, that is numbers, and then hit Control Enter, you can see that inside plots on our bottom right panel, there is a plotting value of your numbers. So 1, 2, 3, 4, and then 5. So this is a very simple plot, and this is just for visualization. And congratulations, you just created your first R plot. And that wraps up our episode 1. You installed R Studio, learned the interface of R Studio, that is these 4 panels right here, and also created a bunch of variables and executed a bunch of functions. So don't worry if you didn't catch all of the concepts. Like I said, this was just for demonstration. We will be discussing about all of these in detail in our upcoming videos. So in episode 2, we'll be diving deeper into variables, data types, and how R handles information behind the scenes, all at a beginner's pace. So if you found the video helpful or want to learn more of R, hit that like button and subscribe to our channel for more such videos. And until the next time, bye bye and happy coding. Hey everyone, and welcome back to the R Programming for Beginners series. And in today's episode, we are going to take a step towards our first real-world programming concepts, and those are variables and operations. And understanding these will unlock everything that we do next in R. So without further ado, let's get on with our video. So as our first topic today, before we get into coding, let's understand what are basic operations. Operations simply are actions that a computer performs, which are often math-based but not always. They can be add, subtract, multiply, divide, which are arithmetic operations, or comparison operations like comparing values with the lesser than or greater than symbol, and they can also be operations like combining values to calculate something new, like reassignment. So you can think of them as instructions that we give into a computer. So we enter instructions into the computer performs an operation, and then gives us an output. So that is how operations work. And now that we have discussed about what basic operations are, let's talk about variables. So what is a variable? A variable is a name that stores a value or some data for later use. Just like labeling a jar, you put something inside and then later you can call it or retrieve it anytime you want. Variables help computer remember information like numbers, texts, and even results of calculations like this. Let's say x is a variable, a name that stores a value of 20. Next up, we use another variable, that is y, which stores a value of 30. And we use a basic arithmetic operation, that is adding these two variables. And then we can store the value of these variables in another variable, or let's say we can use the value of these variables to perform an operation. So when we do x plus y, it gives us a result of 50 instead of doing 20 plus 30 every time. Now, after learning about what a variable is, a question might arise. Why do we even need variables? Can't we just type out the values themselves and perform operations directly? Well, without variables, we would need to type everything again and again. With variables, we can store values, we can reuse those values, and then we can update them and also make use of those variables to build some logic. And this is the point where simple math becomes programming. Now, when you can see, after or let's say before using variables, we would have to perform the same operation time and again. 5 plus 3, 5 plus 3, 5 plus 3, 5 plus 3. But after using a variable, we can store that operation, or let's say the value of 5 plus 3 in a variable called x. Then we can use x itself. We can use the value of x to update the variable. So x plus 2, this results in 10. And we can also update the variable by multiplying the variable. This reduces the need for typing all of this expression again and again. And we can also print the variable. So this is why we should use variables. They help us to store information, reuse information, update our information like this, x plus 2 or x times 3, and then build logic as well. So with a variable, you don't have to type the same value again and again, just use the variable. Okay, now that we are familiar with what variables are, why do we need variables, and what basic operations are, let's talk about how we will be working today. First, we'll explore how operations work in R, that is, we'll use R like a calculator to perform arithmetic operations. Then we will create and print the variables by storing values in the variables. Then we'll update the variables and see how they change, and then talk about some common naming rules that we have to follow, and then also discuss about common mistakes that beginners might make and a recap of the entire video. So let's get on over to RStudio and work with some practical code. Okay, so in order to actually practically work with R, we have to first open up RStudio. So this is the interface of the RStudio. Now, if you don't have RStudio or R installed on your device, I suggest you check out our previous video, which was related to Introduction to R and a setup and installation of both R and RStudio. Now, in order to start working with R, let's first use R as a calculator. So in order to do that, we'll be executing some of the operations that we discussed before in the R console instead of creating any script right away. So let me just increase the size of this for you guys so that you can easily view what we are doing. Now first, let's do 2 plus 3 and then hit enter. And you can see that it gives us an output of 5, which is basically performing the add operation. But if you notice next to the output, we have a set of square brackets, and inside those square brackets is the number 1. Now as a beginner, you might be wondering what that means or why is that there. And well, to understand that, you need to know that one of the basic and fundamental data structure in R is a vector. A vector is basically an ordered collection of elements of the same type. So unless you explicitly define an object's type, it will default to a vector. So the default option for the data structure for that object will be a vector. And this number 1 just means that 1 is the index position of the value that we are seeing right now. So 5 has an index position of 1 inside a vector which only has one element, which is 5. So that is why you are seeing this 1. So you don't have to worry about this being shown. It won't affect any of our code at all. So I just wanted you to understand what that means. Okay, now that we have seen the addition operation, let's do some subtraction as well. So let's do 10 minus 4 and then hit enter. And you can see that it outputs to 6. We can also do multiplication by doing 5 times 6. And the way you actually multiply is by using this asterisk sign. And 5 times 6 is 30, so it outputs to that as well. And then if you want to do divide, it's 20 divided slash by 5, so it's 4. And then if you want to perform exponential operations, so let's say I want to do 2 to the power of 3. So this is the power symbol right here. And then I can do enter to find out the result. Now, of course, as with normal mathematics, operations in R have order as well. I'm talking about the order of operations. So if I do 2 plus 3 times 4, of course, priority is given to the multiplication operation. So it will be 4 times 3 is equal to 12 and plus 2, and that will equal to 14. And if I use a parentheses, so let's say 2 plus 3 and then times 4, it will output to 20, since this will take priority first since it is inside the parentheses. So it will output to 20. Now that we have performed our basic operations, let's start with creating and working with variables. Now instead of typing values repeatedly, we can store them in variables. So for doing that, I'll actually have to create an R script by going to File, and then New File, and then R script. So this is our R script. So let's save this right quick. Let's say this is a variables. Okay. Now inside our script, let's create some variables. Now, as I said before, variables are named containers. So let's say our variable's name is X. And the way you actually store values inside a variable is by using an arrow symbol. Now you can recreate the arrow symbol with the help of a lesser than symbol and a hyphen, and then you can write out the value you want to store in the variable. So you can do, let's say X holds the value of 10. Now, in order to actually execute this storage inside the variable, you can either click on run and it'll store your value. It says X is assigned, or let's say 10 is assigned to X, so X holds the value of 10. And if you observe on our environment panel, you can see inside values that X holds the value of 10. So that is how you assign values to variables. Now instead of using arrow, you can also use an equal sign. So it's let's say y will equal to 5. And the way you can execute this assignment is by either clicking on run, as I mentioned before, or doing, let's say I want to click on this line and then doing control plus enter. So if I do control plus enter, it will execute this assignment operation inside R. So you can see that y is equal to 5, and then our values, inside our values, y holds the value of 5 as well. Now, using the arrow symbol is a traditional way to store values inside variables inside R, and this is kind of a modern, or let's say newer way. I'll be using the traditional way since I want to honor our tradition. And if you feel like it's a hassle typing out the let's say arrow symbol manually, so it is a hassle kind of, you can directly type out the arrow symbol just by pressing Alt and then hyphen. If you press Alt and hyphen, it will create an arrow symbol for you guys. So let's say I want to assign a value of 15. Now as I said before, I'll do control enter and it will execute the assignment. So Z, or let's say Z, holds the value of 15. And that is how you create variables. And now that we have defined our variables, let's get on with printing them as well. Now you can print the values of variables inside your console just by typing them. So if I wanted to print the value of X, I could do X and then hit control enter and it would print out the value of X. Same with Y and same with Z. So X is 10, Y is 5, and Z is 15. Now if you want to print out the value of variables, you can also use the print function. So print and then X, and if I execute this line by clicking on this line and hitting run or control enter, you can see that it outputs the value of X as well. Now R automatically prints the value when we mention the variable's name and hit run or control enter, so you don't necessarily have to use the print function, but it's your choice at the end. And now that we know about printing variables as well, let's discuss about naming these variables. So let me clear all of this and talk about some naming rules. Some valid variable names would be, let's say, age, and I'll hit Alt plus hyphen to create an arrow symbol. Let's say my age is 21, and then hit control enter, and you can see that it registers the value of age as 21. Another value method would be to use an underscore. So let's say I want to create a two-worded variable. So let's say I want to create a variable called total and underscore value. This is how you would create a two-worded variable. So let's say I assign this as 100 and hit control enter. You can see that it registers and saves the value of total value as 100. And finally, another method that you can use to name your variable is by using what's called a lower camel casing. And the way you create variable names with lower camel casing is first you use the small letters, let's say my, and then a big letter, or let's say capital letter, to separate your names. So say if I wanted to create a variable that's called my variable, it has two words, right? You would separate the two words with a capital letter of the second word. So let's say my name. So Alt and then hyphen, and let's say my name is Sam, and then I hit control enter and you can see that it registers as well. Now let's talk about some invalid methods that you don't want to be using, or let's say you don't want to use when creating variables. So if I remove all of this, so let's say I create a variable, and the first invalid thing that you shouldn't do is writing, or let's say starting your variable name with a number. So if I create a variable called toName and then try to assign it a value called, let's say, Sam2, if I hit Control Enter, you can see that it gives us an error in the console. Error, unexpected symbol in toName. So you can see that we cannot start our variable name with a letter, or I mean number. So after that, we have separating our variable names with a hyphen. Now we have seen that in the case of us having two-worded variables like my name and total value, we have separated the two words with either a camel casing like this or underscore value like this, total value. But what we cannot do in R, unlike other programming languages, is separate our words with a hyphen. So if I wanted to create a variable called my and hyphen name and then assign a value to it, let's say Peter, and hit Control Enter, you can see that it will give us an error, object my not found. So this is one of the ways that you cannot create a variable. And the final way that you should not create a variable is pretty common sense if you are familiar with programming, but it is by adding a space between your words. So let's say I want to create a variable called my name once again, but this time I just separate the two words by a space. But you cannot do that to assign a variable. So let's say I do this Sam2 and Control Enter. You can see that it will give us an error as well, unexpected symbol in my name. So those were some methods that you cannot use to create a variable, or let's say those were the naming rules that you have to consider while you create a variable. Now after discussing about the naming rules, let's learn about how you can update the values of these variables. So let's say I want to update my value of x. So as you can see, x holds the value of 10. So if I print out x and hit Control Enter, it will give us a value of 10. Now what if I want to update the value of x? If you want to update the value of a variable, you just reassign that update to the variable. Now what I mean by that is, if I want to, let's say, increase the value of x by 5. So I want to technically increase the value of x by 5, right? This is what I want to do. So if you want to update the variable, you just do x and then the arrow symbol once again, and then just write the update that you want. So I want to increase the value of x by 5, so I type out x plus 5 and then reassign this to our already existing variable. Now if I do this, you'll be able to see that it will result in the value of x being stored as 15. Now if I do x and then hit Control Enter, and then it will output to 15. So that is how you update variables in R. Okay, we have talked about the naming rules of variables, how to update variables, but let's actually use the values of the variables to perform an operation. So once again, let me remove all of this and create two new variables. A will be assigned as let's say 5, and then B will be assigned as let's say 3. Now one thing that you have to be careful, or let's say one thing you have to consider while working with variables is, unless you specifically run this line and this line, or both of these lines together by using either run or Control Enter, you'll notice that the values of A and B will not be stored. So if I try to output A plus B and do Control Enter, you'll see that it says object A not found. Now that is because we only tried to execute this line and not these lines. If we execute these lines by selecting these and hitting Control Enter, you'll see that finally it registers the value of A as 5 and B as 3. And also in the value section in our environment variables, you can see that it registers the value of A and B as 5 and 3 respectively. So always note that you have to execute these assignment variables, or let's say our assignment operations to our variables, before you use those variables. So now finally, if I do A plus B and I hit run, I meant to click on this line, it will output to the actual sum. So when you want to execute a line, you want to click on that line and click on run. So I hope you are aware of that. Now let's say I want to store the result of this addition operation in a variable as well. Now how would I do that? I would do that by creating a result variable and then storing this A plus B value inside that. So if I do run, it will actually create a result variable, and you can see that it updates the value as 8. Now if I type out result, or let's say for clarity I do print result and then hit Control Enter, it will actually print out the result, that is 8. So that is how you work with variables inside R. Now if you have noticed, since we created a lot of variables up until this point, the panel which shows our environment variables, which is this panel right here, is looking kind of cluttered. Well, it is populated with all of the variables that we have created so far. So if you want to remove some variables from the environment, or if you want to remove the variables altogether, you can do that by executing a command called rm, which stands for remove. And then let's say I want to remove the value of a, or let's say I want to remove the variable a entirely from this environment. So I would do rm, and inside the parentheses I would just type out a and then hit Control, or let's say just enter if I'm doing this inside the console, and you'll notice that the value of a has vanished from our environment variables. Now if I remove all of this and I type out a and hit Control Enter, you can see that it says object a not found, which means that it has been removed from our variables inside our environment. But if I type out b and hit enter, it will still output the value of b, since it is still present inside our environment variables. Now if I want to remove all of these variables altogether, and let's say I want to restart the R environment fresh, I would have to use the rm command once again. But since I want to remove all of the variables, I would have to type out list equals ls and then a pair of parentheses once again. Now if I do Control, or let's say just enter, you can see that it will remove all of these values. So if I type out b and then hit Control Enter, it will say object b not found, because all of the variables have been removed from the environment. Knowing this is good information if you want to restart a session. That was basically it about variables and operations. But let's talk about some common beginner mistakes that beginners might make. First of all, like I talked before, one of the mistakes is forgetting to run an assignment. So let's say I type out a is 2 and then a is let's say b is 3 once again, or let's say 34. I mistakenly typed out 34, and then c will equal to a plus b. Now one would think that if I run this program right here, it would output to 34 plus 2. But as I mentioned before, if you have not executed these variables, or let's say if you forget to run these assignments in the R environment, you will not register the value of the variables. So if I select all of this and hit Control Enter all together, you can see that all of these variables have been assigned as well and have been run in our environment as well, if you can see in the console. So that is the thing that you have to keep in mind. Another mistake that beginners might make inside R is forgetting that R is case sensitive. So meaning that whether you type my name or type my underscore name, these variables are different. Now I'm pretty sure that most of you might know that these are different variables and these can hold different values. So let's say I assign this a value of 3 and assign this a value of 5. So if I type out, okay, first of all, let's execute these, and then if I type out my name and hit enter, it will output to 3. But if I choose my name underscore name and hit Control Enter, it will output to 5. So pretty common sense, but still some people might make a mistake. Now another mistakes that beginners might make is using a backwards assignment arrow for our variables. So let's say I do 10 and then assign arrow, but this is backwards. Remember, it should be like this. This is the default or the standard way of assigning variables. But if I do it opposite and then assign a value of 10 to x, this still works, but it is not recommended. It reverses the normal reading direction, which makes code harder to interpret at a glance. And most R users, packages, and style guides follow the convention of using the normal, or let's say the actual arrow operator for assignments. So to keep your code clean, readable, and consistent with the R community as well, it's best to avoid the backwards arrow. So I hope that is clear up for you guys. And that was it for this video. Now let's have a recap of today's topics. Today we learned many things. First of all, we learned how to use R like a calculator. So we learned that R works like a calculator. Next, we learned how to use variables to store values. And then we learned about how we assign those values to our variables as well. And then we learned about how we should name variables and how we should not name variables in order to avoid errors. And then we learned about the print function as well. And then we looked at some common errors and fixes as well. So that was about it for episode 2. If you liked the video or found the video helpful, make sure you drop a like and hit the subscribe button for more such videos. And inside episode 3, we'll be discussing, or let's say moving on to data types in R, numbers, text, logical values, and how R interprets those data types. So make sure you tune in for the next episode. And until then, bye bye and happy coding. Hey everyone, and welcome back to the R Programming for Beginners series. Now in the previous episode, we discussed what variables are and how basic operations work in R. And now that we know how variables and basic operations work, it's time to understand something even more fundamental. That is data types, the form in which R stores and understands information. Different data behaves differently, and knowing the data type helps us work with it properly. Now, as the first topic for this video, let's discuss about what are data types. Now, every value that we use in R has a type, just like objects in real life. Numbers, words, yes or no, R stores each kind of data separately. R mainly works with 3 base data types for beginners, and they are, first of all, numeric data, which can include decimals as well. Next up, character data, which includes texts, words, or strings. And then finally, logical data, which are basically either true or false values. And we'll be exploring each one with examples. So, first up, let's talk about numeric values or numeric data. Numeric values represent numbers that we can calculate with, like heights, salaries, and scores in a game or a match. The examples of numeric data include numbers like 5 and -12, and also decimal values like 3.14 or 0.99. Most numbers in R are stored as doubles, which are decimal values, even if they look whole. So even a simple integer like 2 is conceptually stored as 2.0, and decimals like 2.2. Okay, now that we know about numeric data, let's talk about character data or strings. Character data represents texts. That includes names, messages, dates which are stored as text, and also anything inside quotes. Examples of the character data type include stuff like hello, Sam, or even R programming. All of these are character data or strings. Basically, if it's in quotes, it's a character, even if it looks like a number. So even if a number was stored inside a variable using quotes, or let's say the number was wrapped with quotes, it would be a character data or a string. Okay, so we have covered character data as well. Now let's talk about logical data. Logical values represent true or false, which are going to be useful for decisions and filtering on later. These logical values can be returned by expressions as well. Suppose we have a comparison operation called 5 is greater than 3. Now this is true. 5 is greater than 3, so this expression will return a true value. Let's take another example. Suppose we have yet another comparison operation, and this time it is comparing the value of 2 to that of the value of 10. Which is done by using this double equals to sign inside R. This is comparing if 2 is equal to 10. Now this is obviously false, so this will return a false value. So that is about it when it comes to logical data. These will become powerful when we get into conditional statements later. So we discussed about the 3 types of data that we will be working with in R. Now let's discuss about a common beginner problem, or let's say a common beginner confusion, that is integer versus double. Now when talking about numerical data types earlier, we stated that numbers in R are stored as doubles by default. That means even whole numbers are stored as double by default. Now, if we want to force the number to go from being a double data type to an integer data type, we would have to add an L suffix. That is, we would have to add an L at the end of the number. So, let's say we had a number 5, which is by default stored as a double. If we wanted to convert this into an integer, we would have to add an L suffix, which is done by doing this, 5L. Now, this 5 would be an integer. Now, this might seem insignificant at the moment, but the distinction matters when precision or memory matters when we execute operations later on. So, now that we have discussed about separating doubles and integers when working with numbers inside R, let's talk about how to actually check those data types in R. So this is going to be the final topic for the video. Now in R, we can ask two different questions about our data. So this is going to be about how to check data types. First of all, the first question is what is the data? And the next question is how it is stored. First of all, we have the class function. Class answers the first question. It tells us about the high level category of the value. For example, if the data is numeric or the character or logical data. But R also stores data internally in different formats. That is where the function typeof comes in. It tells us the low level storage type inside R's memory. For example, when we write the number 5, its class is numeric, but its internal type is double because R stores numbers with the decimal precision by default. So think of it like this. Class is the label on the box. It tells us what kind of data we are working with, whereas typeof tells us what's inside the box, how R actually stores that information. Most beginners only need the class function at first, but later you'll see why typeof function matters when working with performance or precision. And that's it for episode 3. And as a recap of today's topics, you now understand numeric values, character strings, logical values such as true or false, the difference between integers and doubles, and how to check each data type. And in the next episode, that is episode 4, we will be looking into type conversion in R, that is converting one data type into another type. So hope you tune in for that. If you like this video or found this video helpful, please drop a like and subscribe to the channel for more such videos. And until the next video, bye bye and happy coding. Hey everyone, and welcome back to another video of the R Programming for Beginners series. Now in the last episode, we learned about data types, that is numeric, character and logical data types. The difference between the integer values and double values, which are under numeric data types, and how to know the data types of variables that we declare in two different ways. And today, we're taking it a step further and learning how to convert one data type into the other, which is something you'll use very often while working with data. So, without further ado, let's get into the first topic for this video, which is, as always, what is type conversion? So, as the first topic of today's video, let's understand what is type conversion. Type conversion is simply changing a value from one type to the other. For example, converting a character string like 42, which is wrapped inside quotes, that's how you know it's a character string, to a numeric value of 42. So we can do calculations with this value as well, which is the freshly converted value. Another example can be converting logical values like true into a character string like true. Since it is wrapped inside these quotes, it is a character string. Now, R gives us built-in functions to do this very easily, and by the end of this episode, you'll know exactly how and when to use them. So, the functions that we'll be learning today. There are 3 conversion functions that we'll be focusing on in this episode. Number 1 is as.numeric, which converts values into numbers. And next is as.character, which converts values into text. And then finally, number 3, we have as.logical, which converts values into true or false. Now these 3 are enough for a beginner to work with almost any dataset. So let's first see how they work, and then we will execute the conversion functions in our very own R compiler. So, coding demonstration. First of all, let's convert a character into numeric. For that, we would need to use the as.numeric function. Suppose I have a variable called x and I have 42, a value of 42, which is a string value, as you can see from the double quotation, to assign to this x variable. Now if I convert as.numeric x, that is I convert this value into a numeric value, it converts the string value of 42 to the numeric value of 42. And if we check the data type of x using class, we'll be able to see that it converts into numeric value, and the output will be like this. So let's open up our very own compiler by going to coding.com. You don't have to open up RStudio for stuff like this. So to test out code, or if you want to test code on the go, you can just go to coding.com, head over to compiler, and we have multiple languages to choose from, and one of them is R. Now after we click on R, our compiler will open, and let me just increase the size of this website for you guys so that you can see properly. Now what we will do is we'll execute this same code and observe our output. So first of all, let's create a variable x and then assign it a string value of 42. Now when we do let's say print x, what will happen? You can see that it outputs to 42. But what will happen if we do as.numeric, that is converting this into a numeric value, and then x? Let's execute this, and you can see that a numeric value of 42 is outputted. Notice how before we had the quotes, and now inside the output we don't have any quotes, meaning that this value is converted. Now let's also do this. We'll find out the value of x, but also I meant data type, and also we'll find out the data type of as.numeric and then inside x. So we'll run this. Now you can observe by this class function that when we try to find out the data type of x, it still returns characters since originally it had a character data type. But when we convert this data type into numeric and then find out or let's say then execute the class function, numeric data type is returned, meaning that this holds a numeric data type. So that's how you convert a data type into numeric. You use as.numeric. So I hope that is clear for you guys. So after executing this as.numeric function inside our very own R compiler and observing the output, let's move on to another type of type conversion, which is converting the numeric data type into the character data type. And we can do that by using the as.character function. Now what this does is similar to as.numeric. This converts the numeric data type, which is represented by y, into a character data type. So if we have a numeric data called 99, when we use the as.character function, it will convert it into a character string, which is represented by quotes 99 and double quotes. So it will be the expected output. Let's try this inside our compiler as well. So when we move on to this, let's remove all of this, create a variable called y, and then assign it a value of 99, and then we will use as.character and then y. And what we'll do is we'll also print out the data type of as.character. So let's run this. You can see that first it will print out, okay, we'll also do print y. Now you can see that first of all, when we print y as it is, it outputs to a numeric data type, which is a value of 99. And after we do as.character and wrap it, or let's say put y inside the argument, it will output to a string value or a character data type. And when we use the class function to actually check the data type, it returns character. So we have successfully converted a numeric data type into a character data type. And now finally, we arrive at our final conversion, that is converting into logical. And the function that we will be using to convert values into logical data types is as.logical. Now as I said, logical conversion works a bit differently. Here, 1 always becomes true. Next, 0 becomes false. And then the word true is also valid, since it is just the logical value of true. It is just wrapped inside double quotes. So if we try to convert a string value of true into a logical data type, it converts into the true value. But normal strings don't work. Hello will return an A, meaning that it doesn't, or let's say R doesn't understand how to convert it. Now let's try all of this inside our compiler as well, and we will arrive at our ending, that is common beginner mistakes that you guys might make. So first, let's go over to our compiler once again, and let's try to convert each and every value. So first we'll do as.logical 1, and let's see what it outputs to. You can see that it outputs to true. Let's do as.logical, logical 0, and let's see what it outputs to. You can see that it outputs to false. Now for the two values, we'll do as.logical, and then inside quotes we'll type out true, or let's say all caps true. Let's see what it outputs to. It outputs to true. But when we try to do as.logical Okay, my bad, caps lock is on. as dot logical, and then let's say hello world. What will happen? It will return an A value, meaning that R doesn't know how to convert this into a logical data type. So I hope logical conversion is clear to you guys as well. After discussing about logical type conversion as well, let's come to our final topic for the video, that is common beginner mistakes. It is very important to avoid these mistakes. So first of all is converting non-numeric values, or let's say non-numeric text, to numbers. So when we do as.numeric and we try to convert a non-numeric string value like ABC, it will give us an A value. So this is super common when importing CSV files. A numeric column might be stored as text, so it might give you an A value. The next mistake is forgetting quotes. Now I know that even if this value had quotes, it would give us the first error, that is an A value, since this is not a numeric value. But that's not the point. Without quotes, R thinks that ABC is a variable name, and since we never created it, R will throw us an error, which is object ABC not found. And the next and final mistake is converting mixed vectors. So if we have a vector that is just a collection of items as 10, 20, and then cat, as numeric would convert the first two values, that is 10 and 20, since they are numeric values just wrapped inside quotes, but it would give us an A value for the third item, that is cat. So these are the basic mistakes that beginners must avoid. Now let's have a summary, or let's say a recap of today's topics. We learned about as.numeric, which converts character values into numeric values. Next, we learned about as.character, which converts numeric values into character values. And then we learned about as.logical, which converts values into logical values such as true and false. So we have our recap table right here, and you can take a look at it to have a recap of today's topics. And with that, we have successfully wrapped up episode 4. Today we learned about how to convert data from one type to another using many functions, namely 3 functions, that is as.numeric, as.character, and as.logical. I hope you liked the video and found it helpful. If you found the video helpful, please drop a like and make sure you subscribe to our channel for more such videos. In the next episode, we are going to be moving into one of the most important topics in R, that is vectors, and we'll study them in detail, so hope you don't miss that. And until then, bye bye and happy coding. Hey everyone, and welcome back to the R Programming for Beginners series. Now in the last episode, we learned how to convert between data types, and it was a fairly short and simple topic which I hope you guys understood well. And in today's episode, we're going to be stepping into something fundamental to R, that is vectors in R. Now this topic is fundamental because almost everything you do in R, things like storing values, calculations, data cleaning, etc., starts with vectors. Now this is going to be a big episode, so without further ado, let's get on with our video. And before we move on with the video, a quick shout out to the R Programming Learn and Code app from Codin inside the Google Play Store. With this app, you can learn R right from your phone, anytime and anywhere. And there are engaging and interactive courses on the app that make learning fun. And with quick facts and quizzes inside each course, you'll be truly understanding R and not just memorizing it. It also has an R compiler which allows you to type and test any bits of R code that you want. So if you want to learn R and are looking for somewhere to start, do check out the R Programming app from Codin inside the Google Play Store. Now let's move on with the video. Now, like with every video, let's start with a basic question. What is a vector? A vector is simply a collection of values. Now these values v1, v2, v3 and v4 can be numbers, text or logical data which are stored in order. So all of these are data, and this individual v4 is a data value in itself, and these are stored in an order. Now think of it like a row of items that are arranged in one straight line. One value alone is a data, but multiple values together become a vector. And like I said before, the vectors can be a numeric vector like this. It is a collection of 10, 20 and 30, and also character vectors like this: apple, banana and mango. Now R loves vectors. Even single values are treated like tiny vectors of length 1. Now, if you've watched our previous episodes where we have executed functions and code in R, you might have noticed that the result in the console has a 1 next to it inside square brackets, and that is basically the index position of a single valued vector. And now that we have some basic knowledge about what vectors are, let's learn how to create them, shall we? So let's come to our next slide, that is creating vectors. Now, in order to create a vector in R, we use the function C, which stands for combine. When using the combine function, inside these parentheses, we list all the values that we want to store inside of a vector. Now, the first vector in the example, which is numbers, stores numerical values with the help of the function C, which means combine, and which tells R to combine all of these values inside a single vector, 1, 2, 3, 4, 5. Now, and inside our second vector, fruits, we have a vector of string values or character values inside the function C, which is clear from the characters being wrapped inside quotes. Now, like I said, these are some examples of vectors that hold both numeric values and character values. So, it's like dropping a bunch of values into a box that is a vector. In the first case, we are dropping 1, 2, 3, 4, 5 into our vector, and in our next case, we are dropping apple, mango, and banana into our vector that is fruits. So, I hope you understand how we can create vectors. Okay, now that we know about creating vectors, let's actually create those vectors inside of our own R compiler. So let's head over to Codin.com and then go on to the compiler section and then head over to the R compiler, which is right here. So if we click on R compiler, we'll be greeted with this compiler right here, and let's create a vector now, shall we? So, in order to create a vector, let's actually create the two vectors that we discussed before. There's numbers and an arrow symbol, and let's use the C, that is combine function, to create a vector of 1, 2, 3, 4, and 5. And after that, let's also create a vector of fruits, and let's store some fruits names inside it. So let's say mango, and then banana, and let's say kiwi. And when we run these, let's see what happens. So it outputs to nothing since we have not outputted them. So let's say numbers and then fruits. Let's now run this and check our output. So we have a vector of 1, 2, 3, 4, and 5, and a vector of mango, banana, and kiwi. Now, before we start working with vector operations, let's actually discuss indexing elements first, which is very important. So let's head on over to our slides. So indexing elements inside of a vector. Now, once we have a vector, we often will need to access individual values of the vector. In R, indexing of elements in a vector starts from 1 and not 0, unlike most programming languages, which is a common detail that beginners might miss. So, if we had two vectors, or let's say if we had a vector called numbers and then square brackets 1 would access the first element, whereas numbers and then square bracket 3 would access the third element, and it is pretty straightforward. So all of these would be indexed as 1, 2, 3, 4, and then 5. And if you come from Python or JavaScript, where indexing of these types of collections start with a 0, welcome to R's unusual world. Now that we have discussed about indexing, let's actually demonstrate it inside of our compiler. Let's access let's say, third element of our numbers and then the second element of our fruits. So what will happen if we do this? It will return 3 as the third element, so it is the third element, and banana as the second element, since it is the second element of the vector called fruits. So I hope indexing elements is clear for you guys. Now, after talking about accessing the individual elements of a vector, we arrive to one of the coolest things about vectors in R, and that is vector operations. The cool thing about vectors in R is that they can perform operations on all elements at once. For example, if I had a vector called A, which stored a collection of 2, 4, and 6, if I did A plus 2, it would add 2 to every element of the vector, and we would end up with 4, 6, and 8. And likewise, if we did A times 3, we would be multiplying every element of the vector by 3, and we would end up with 6, 12, and 18. Now this allows us to add and multiply all of the numbers of the vector instantly, no loops required. Now this feature makes R amazing for mathematical work and data analysis. And not just adding a single value to all of the elements, we can also add two separate vectors to obtain a combination or a sum of the vectors. So if I had a vector called A, which had 2, 4, 6, and B had 1, 3, 5. If I did A plus B, it would return a sum of both these vectors. So 2 plus 1 would equal to 3, 4 plus 3 would equal to 7, and 6 plus 5 would equal to 11. Now, instead of doing all this, I'll just demonstrate the vector addition. So let me just copy this code right here, and I'll just put it in our R compiler, and then let's see what happens. So if we do A plus B, you can see that 2 plus 1 will equal to 3, 4 plus 3, 7, and 6 plus 5 will equal to 11. Now, okay, for the sake of the video, let's just do A plus 2 as well, and let's see what happens. So it returns 4, 6, and 8, which is just adding 2 to every element of the A vector. So I hope vector operations are clear to you guys as well. So like I mentioned before, with the help of vector operations, we don't require any loops to work with individual elements of our vector. Now, on the topic of adding and performing operations with vectors, we arrive at a concept that is unique in R. So do pay attention. And that concept is the recycling rule. If you operate on vectors of different lengths, R recycles the shorter one, or let's say the vector with the shorter length. So if we had two vectors, let's say x, which stored a value of 10, 20, 30, and 40, and y, which stored the value of 1 and 2 only, R would repeat the values of y to match the length of the larger vector, which in our case is x, which holds 4 values, whereas y holds 2 values. So while doing the operation of x plus y, R would repeat y as 1, 2, 1, 2. So since y only has 2 values, R repeats them to match the length of x. So the operation becomes 10 plus 1, 20 plus 2, 30 plus 1, and 40 plus 2. It is clever, but it can also bite you later if you're not expecting it, so be careful when vector lengths don't match. So after discussing about the unique concept that is the recycling rule, we arrive to the final topic of today's video, that is length and sorting in R. Now, the length function tells us how many items a vector contains. So if I had a vector called numbers and it stored the numbers 2, 4, 6, 8, 10, the length function would give us a value of 5, since there are 5 elements that are stored inside of this vector. And next, for sorting values, we have the sort function. Now, using sort as it is would sort the numbers in an ascending order, but if you want to sort the numbers in a descending order, you can turn the decreasing value to true, which will in turn arrange the numbers in a descending order. So if we had a number, or let's say a vector of numbers called 20, 10, 40, and 30, using sort would arrange it as 10, 20, 30, and 40, which you notice is ascending. So before we head over to our recap slide, let's run, or let's sort our vector right here. So inside this very vector, let's create 23, and then 22, and then 4, and 8, and 7, let's say. And let's use the sort function on our vector, that is A. And let's run this to see what it outputs to. So it outputs to 2, 4, 6, 7, 8, 22, and 23, which is sorted in an ascending order. But let's see what happens when we turn the decreasing parameter, so decreasing, to true. So when we do that, you can see that it is sorted in a decreasing manner. So 23, 22, 8, 7, 6, 4, 2. And that is basically how sorting, and okay, I didn't demonstrate length actually. So if I did length and then A, let's see what it will output to. So it will output to 7, since there are 7 values inside of our vector. Okay, now that we have talked about sorting and length as well, let's head over to our recap slide, shall we? So, as a recap of today's topics, we learned first how to create vectors in R, that is with the C function, that is combine function, how to index values, or let's say how to access individual values of those vectors, how to perform vector math and vector operations, the recycling rule in R, and about length and sorting as well. And that wraps up episode 5, vectors. You just learned one of the most fundamental structures in R. Now in the next episode, we move on to something even more exciting, that is lists. So in order to know more about lists and what lists are, hope you tune in for the next episode. If you found this video helpful or like this video, make sure you drop a like and subscribe to our channel for more such videos. And until the next episode, bye bye and happy coding. Hey everyone, and welcome back to the R Programming for Beginners series. Now in the last episode, that is episode 5, we explored vectors, one of the most fundamental data structures in R. And we saw how vectors are used to store multiple values together. And an important thing to note about vectors is that a vector stores values of the same data type. But what if you want to store different types of data together? Let's say a number, some text, some logical values, or even other vectors, all in one place. Well, that's where lists come in. And in today's episode, we're going to be diving into lists. So without further ado, let's get on with the video. So what is a list? A list is like a container where you can store different types of objects together. Well, it can hold numbers, it can hold character data as well, it can hold logical data, and it can also hold vectors and other lists, all in one place. You can think of it like a shopping basket. You don't fill it with only apples, you can drop in bread, milk, eggs, whatever you want, and that is the case with lists. So now that you have a basic idea about what lists are, let's see how can we create a list. Well, inside R, you can create a list with the help of the list function. So the function list and then the types of, or let's say the list of values that you want to create a list with inside the parentheses creates a list. Here we have created list with the list function, and inside it we put a number and a character value which is noted by R, then a true or false value which is a logical value, and a vector called, well, it's not called anything, it's a vector of 1, 2 and 3 as well. Notice that we don't have any requirements for them to match, and that is what makes lists extremely powerful. Well, now that we know about the theory of creating a list, let's actually create a list inside our R compiler. So inside it we'll create a list called myList, and then an arrow symbol, and then the list function, and inside the values. So first of all, let's store a 10, and then a string value of R, then a boolean, or let's say a logical value or true, and then a vector. So 1, 2 and 3. Now let's print out our list. So my list, and let's run, and it will give you an output of the list. Now instead of the usual output, I know there are 2 square brackets and then a single square bracket, then our actual item, then 2 square brackets, the index position of 2, and then the actual item. Well, this is because of the list's nature in R. The double square brackets that you see in the output are R's way of showing the structure of the list. They label each element of the list. Since this element, that is 10, is stored at the index position of 1, it has 1. Similarly, R has 2, and inside it, it is stored at the second position, and same for true and C, 3 and 4. And let me tell you, these are sublists on their own. And we'll actually discuss more upon this in the later topic, that is accessing list elements. But for now, let's know why does R love lists. So why does R love lists? Lists appear everywhere in R, in regression models, in summaries, in data frames, you name it. Whenever R needs to return a lot of information with different data types, it packs everything neatly into a list, like this. So, learning about lists early is essential, because later you'll be extracting data from lists non-stop. So, to know more about lists, let's talk about accessing list elements. In R, you have 2 ways of accessing a list element. Technically, it's one way to access the actual element, and another way to access a sublist. First, we have the single bracket. Using a single bracket followed by an index position on a list returns a sublist. So my list with the square bracket 1 would return a sublist which contains the first element inside the list. Next is the double bracket. The double bracket returns the actual value of the list. So if we do double bracket, it would return the actual element. So let's say our first element in the previous slide, or let's say our example, was 10. Doing my list and then double bracket 1 would actually return 10, but doing my list with a single bracket and 1 would return a sublist which contains the value of 10. So that is the key difference. The single bracket gives you a smaller list, like taking a box but not opening it, while the double bracket, or let's say the double square bracket, opens the box and actually gives you the object that is inside it. And you will see this everywhere in our scripts. And now you know exactly why. So let's try this inside of our compiler, shall we? So with our previous output, let's try to access the first element of our list, but with a single bracket. So it should return you a sublist. So gives a sublist. And let's run. And you can see that it gives you a sublist, and inside it there is the value of 10. But what if we do my list and then double square brackets and 1? So this will give us the actual value. Now let me comment this line entirely and then run. You can see that only the value is outputted when we use the double brackets and not a sublist, which is symbolized by the use of these two square brackets. This is a sublist and this is a value. So I hope accessing the actual index elements is clear for you guys. Now let's move on to a very important topic, that is named lists. Now just like variables have names, list elements can have names too, and that is where named lists come in. Now named lists makes data extraction so much clearer. Now when we have a named list, it has a name for each list value. So if our first element was Sam, it has a name for it, which is name exactly. And 21 has a name called age, and this collection, or let's say a vector, has a name called skills. These are the names, and these are the actual elements on the other side of the equals to sign. So how would you access them? We have three ways. One is by using the dollar sign. Person, dollar sign, person is the name of the list, and dollar sign name would give us Sam. Next up, we have the double bracket. Writing the name of the list, that is person, and then double brackets, and inside quotes, the name of the value that you want to access. In this case, let's say we want to access the value of 21. What name does it have? It has the name of age. So if we put age inside quotes, inside the double brackets, it would give us 21. And the next and final way is actually using single brackets in this time as well. Doing person and then single brackets and then the name of the value that you want to access would not give you the actual value. In our case, this would not give us the actual vector which contains R, Python, and SQL. It returns a sublist like in our previous case because of the single bracket rule. So as a recap, the single bracket returns a sublist, the double bracket returns an actual value, and using the dollar sign and then followed by the name gives us the actual value as well, and this is easy direct access since you don't have to type out two brackets. Now let's try to access values of a named list inside of our R. So we have a named list that has the value of name Sam, age 21, and skills, and then a vector of skills. So let's first of all type out, let's say I want to access the name, so let's say person and then dollar sign and the name. Let's see what it returns. It returns us the actual name. And the same with square brackets. If we use square brackets and then wrapped the name inside of quotes, which is a bit tedious, but it gets the same job done, what would happen? Once again, it would give us the actual element. So we can see from this that just using a dollar sign and using the actual name of the value will give us results much quicker. So this is much quicker than typing out two brackets. And let's see what a single bracket would give us. So if we do single bracket and then name, it would actually give us a sublist of Sam. So I hope accessing named list elements is clear for you guys as well. And that was it for this video. Let's have a quick summary of what we learned today. So as a recap of today's topics, these are the topics that we learned today. We learned how to create lists with the list function and learned that lists can hold values of different data types like this. This is the number, this is a character, and this is a logical data type. And yes, we learned that lists can store mixed data, and we learned the difference between using a single bracket and using a double bracket while accessing the list element. That is, the single bracket returns us a sublist, and using double brackets gives us the actual value. And then finally we learned about named lists as well and how you can access those values of the named lists. And that was it for this video. That brings us to the end of episode 6. You now understand lists, what they are, how they're used, and how to extract values from them clearly. And in the next episode, we continue our journey into data structures as we dive into matrices and arrays, unlocking R's power for working with multidimensional data. So I hope you tune in for that, and if you liked the video or found the video helpful, make sure you drop a like and subscribe to our channel for more such videos. And until the next episode, bye bye and happy coding. Hey everyone, and welcome back to the R Programming for Beginners series. Now, in the last episode, we talked about lists and how lists can hold multiple types of data together. And today, we take another step into our data structures, which is matrices and arrays. Now, you can think of them as vectors but arranged into multiple dimensions. Matrices are like spreadsheets. They contain rows and columns. As you can see here, there are rows and columns. And whereas arrays extend that idea into 3D, 4D, or more. Now, we won't go too deep, just enough for you to understand how they work and when to use them. So, without further ado, let's get started with the video. Now, first things first, what is a matrix? A matrix is a rectangular table of data, numbers stacked in rows and columns. Unlike lists, a matrix can only store one type of data. If you mix numbers and text, R will convert everything into text. Think of it like multiple vectors arranged sideways. They are in rows and they are in columns. Now, internally, a matrix is still just a vector. When you combine vectors, it will form a matrix. Now, as for how R stores matrices, R stores all the values in a single line, and the dimensions tell R how to display them as rows and columns. So, now that we have a basic idea about what matrix is, let's see about creating matrices. So, in order to create a matrix, you'll have to use the matrix function, which holds the number of rows you want, the number of columns you want the matrix to have, and finally the data you want the matrix to store. So if you wanted to create a matrix, this is how you would do it. Here we have created the matrix with the numbers 1 to 6. It will include 1, 2, 3, 4, 5, 6. It will have 2 number of rows and 3 numbers of columns. So R fills matrices column wise by default. So first of all, it will be 1, 2, and then 3, 4, and then 5, 6. 1, 2, 3, 4, and 5, 6. So that is how it will fill the matrix. It fills from top to bottom, then left to right. Now, if you want the matrix to be filled by rows instead, we have the option to do that as well. If we include an extra parameter called by row equals true, it will fill the matrix first of all with rows. So first of all, there will be 1, 2, 3, and then it will be 4, 5, 6. So that is how it will go. But the default is column wise. I hope you keep that in mind. Now you can use both of these methods, but you'll see this option used often in matrix creation, which is row wise. So now that we know the theory of how to create a matrix, let's actually create a matrix and print out that matrix on our R compiler now, shall we? So for that, I'll head over to our compiler of our own, coding.com, and then I'll try to create a matrix now. So M will be the name of our matrix, and it will contain a value. First of all, let's use the matrix function to actually create a matrix, and then it will hold the values from 1 to 6, and then it will have number of rows will equal to 2, and the number of columns will equal to 3. So first of all, let's do this, and let's print out the matrix. So as you can see that these are the index position of the columns and these are the index position of the rows. It has filled column wise, as you might notice. So first of all, it will fill the first column 1, 2, then the second column 3, 4, then the last, that is the third column 5, 6. Now we can also try to arrange these with rows. So let's add a new parameter, that is by row will equal to true, and let's observe the output now, shall we? So as you can see that it first fills rows, that is the first row is filled 1, 2, 3, and the second row is filled 4, 5, 6. So that is how you create matrices in R. Now let's discuss about how we can access these individual elements, or let's say access a part of this matrix itself. And the topic will be indexing rows and columns. So like I said, now let's talk about how we can access the individual elements of a matrix, or let's say indexing rows and columns. Now, matrices use the row column format of indexing. So the first value represents the row and the second value represents the column. So doing this would give us the value that is in the first row and the second column. This would give us all of the elements of the second row, and this would give us all of the elements of the third column. So if I did M12, it would give us the element of the first row, that is this, and the second column. So this, it would give us 3. And next, if I did M2 comma blank, if I leave the column position empty, it would return us all of the elements of the second row. So it would give us 2, 4, 6. And finally, if I do m and then first parameter, that is the row value is blank, and then comma, and then third column, it would give us 5 and 6, since these are the elements of the third column. So this is how you can access the elements of a matrix. So once again, let's head over to our compiler and let's try to access the elements. Okay, let's print out m as it is. Okay, I meant to type out matrix, and let's try to access 6 now, shall we? Now if you notice, this 6 is in the second row and the third column. So if I wanted to access 6, I would have to do 2 for the second row and 3 for the third column. This would give us 6. If I wanted to access 2, I would have to first of all pick out its row, that is 1, so m1, and its column, which is the second column, so it is in the first row, second column, so m1, 2. Now it should give us first of all 6, like I said, and then 2. So this is how you access the elements of a matrix. And now we'll be moving on to the topic of matrix operations. Now, as you saw with vectors, with matrices as well, we don't have to work with loops in order to work with the individual matrix elements. We can simply perform matrix operations. Now, matrices shine when it comes to mathematical work, and that includes adding, multiplying, and transforming data in bulk. So, if I had two matrices with the names A and B, with each containing values 1, 2, 3, 4, and then 5, 6, 7, 8 arranged in two rows, A plus B would do element-wise addition, A times B would do element-wise multiplication, and A percentage and then asterisk and percentage B would perform a matrix multiplication. Now we'll be discussing these operations in detail. First of all, we have the element-wise addition, that is A plus B. Now if we had a matrix A and matrix B which had elements arranged in columns, so 1, 2, first column, 3, 4, 5, 6, and 7, 8. Now what A plus B would do is it would add the individual values of the corresponding places. So at the first row and first column position, that is this position right here, this would be added to this, 1 would be added to 5, 3 would be added to 7, 2 would be added to 6, and 4 would be added to 8. You get the gist. So 1 plus 5 is 6, 3 plus 7 is 10, and so on. So the values of the corresponding places of each matrices are being added. So element-wise addition, value with value, position with position. And likewise, we come to the element-wise multiplication. Same with this as well. When we do matrix A times matrix B, what would happen is 1 would be multiplied by 5, 3 with 7, 2 with 6, and 4 with 8. And then we are left with the result of A times B, that is 5, 21, 12, and 32. So this is element-wise multiplication. Yeah, so element-wise multiplication, value with value, and position with position in this as well. And then we come to the matrix multiplication, that is A percentage times percentage B. Okay, I know this symbol can be a bit confusing at first, but you'll get the gist of it. So when doing matrix multiplication, we multiply the rows elements to the individual columns elements. So first of all, when we do the matrix multiplication of A and B, we will do the row 1 of A times each column of matrix B. So 1 would be multiplied to 5, and then 3 would be multiplied to 6. So 1 times 5 plus 3 times 6. Same with the other column. So first of all, one row will multiply 2 columns, and then the second row will multiply the 2 columns once again. So when first multiplying R1 to C1 and C2, we'll do 1 times 5 plus 3 times 6. 1 times 7 plus 3 times 8. So as you can see, 1 will be multiplied to 5 plus 3 will be multiplied to 6. And this will be our first position. So first row and first column. And then this will be our second position, that is first row, second column. And likewise with the second row of matrix A as well. 2 will be multiplied to 5, 4 will be multiplied to 6. These will be added. And then in the other position, that is the final position, 2 will be multiplied to 7, so 2 times 7, and 4 will be multiplied to 8, so 4 times 8. And this will result in our resultant matrix, which is 23, which is corresponding to this value, 31, which corresponds to this value, 34, this value, and 46, this value. Now do keep in mind that matrix multiplication is different from A times B. that is A asterisk B. Matrix multiplication actually follows linear algebra rules and requires compatible dimensions. That is, the number of columns of the first matrix, in this case the first matrix is matrix A, should be equal to the number of rows of the second matrix. So if it has 2 columns, it should have 2 rows. Then only matrix multiplication will be possible. And another point is that inside matrix multiplication, A times B is not equal to B times A. So the order of the multiplication also matters. So I hope you keep those things in mind. So in order to actually demonstrate matrix operations, I have created here 2 matrices A and B. One holds 1, 2, 3, 4 and the other, that is B, holds 5, 6, 7 and 8. And notice that I haven't used the by row arguments, so these will be filled column wise. So 1, 2, 3, 4 and then 5, 6, 7, 8. So let's just print and make you guys observe on that. So A and then B. So if I print these, first of all you'll be able to see 1, 2, 3, 4, that is A, and 5, 6, 7, 8, and they are arranged column wise. Now let's perform matrix operations with them. So let's first of all print A plus B and see the output. So you can see that 5 plus 1 will equal to 6, and then 6 plus 2 will 8, 7 plus 3 will equal to 10, and 8 plus 4 will equal to 12. If I turn this to a multiplication sign, that is an asterisk sign, what will happen? So you will be able to observe that these values, that is the values at corresponding places of each matrix, have multiplied. 5 times 1, which is 1, 1, was multiplied 5, 2, let's say 1, 2, that is 3, and then 7, 3 times 7 is 21, 2 times 6 is 12, and 4 times 8 is 32. So a matrix multiplication is possible as well. Okay, so I have changed the output mistakenly, but let's run this once again and it will print out the output. And now after this, finally we come to matrix multiplication, which is symbolized by a percentage, an asterisk, and then a percentage once again. Now when we do this, you'll be able to observe that matrix multiplication has been performed. Now as I explained before, 1 will be multiplied to 5 and 3 will be multiplied to 6, and then they will be added. So 1 times 5 is 5, 3 times 6 is 18, so 18 plus 5 will equal to 23, and so on. I hope you understood the explanation from before, since matrix multiplication can be a bit tricky. Now I want you to also observe that A matrix multiplication B is not equal to B matrix multiplication A. So you have seen the output of A times B, right, in our matrix multiplication terms, 23, 31, 34, 46. But when we run B times A, the output will change. So this proves that A times B is not equal to B times A when doing matrix multiplication. So I hope you keep that in mind. Now after that, let's learn about arrays. So what is an array? An array is like a matrix, but it can have more dimensions than just 2. It can have 3, 4, or even 10 dimensions. And instead of only rows and columns, arrays add depth. So if I had a variable called ARR and I wanted to make it an array, or let's say I wanted to store an array in the variable ARR, I would have to do it with the array keyword, or let's say the array function. So if I wanted an array with the numbers 1 to 12, then I would have to define its dimensions as well. Now when doing dimension equals C, which is just a vector 3, 2, 2, means that it will have 3 rows, 2 columns, and 2 layers. This is where arrays differ from matrices. Not just rows and columns, it also has layers as well. So in our case, the array would be split into these 2 parts. The first part would, or let's say the first layer would contain 1, 2, 3, 4, 5, 6, and then the second layer would contain 7, 8, 9, 10, 11, and 12. And notice how in arrays as well, the elements are first being filled column wise by default, 1, 2, 3, and 4, 5, 6, and then 7, 8, 9, and 10, 11, 12. So think of it like 2 matrices stacked one behind the other. And you can also think of arrays like matrices with depth. So the rows and columns are the same, but arrays come with depth, and that is basically what you should understand about arrays. Okay, now in order to actually visualize an array and how we create an array inside R, I have created the syntax, or let's say I have written the syntax of how to create an array. So we have a variable ARR, and then we create an array with the array function, and this will hold numbers from 1 to 12, and then the dimensions will be 3 rows, 2 columns but 2 layers. So it will have 2 layers of individual matrices, let's see, which have each 3 rows and 2 columns. So if I print out ARR, it will result to this. So this is the first layer. It will have 1, 2, 3, 4, 5, 6. Notice that it has 3 rows and 2 columns, and then it is arranged in column wise by default. And this is the second layer, which will contain the remaining elements from 1 to 12, that is 7, 8, 9, once again 3 rows, and then 10, 11 and 12, and it has 2 columns. So I hope you understand how an array is created and how an array is displayed inside R, or let's say how it is stored. It is in 2 layers, the first layer and the second layer. So I hope that concept is clear for you. Now, after you know what an array is, let's talk about when should you use matrices or arrays. So when do matrices and arrays really come in handy? Well, they shine whenever you're working with mathematical or numerical data. For example, mathematical modeling, performing linear algebra or running simulations, calculating values on grids or coordinates, and processing images or doing other data transformations. Basically, if your work involves machine learning, optimization, or heavy mathematical computations, you'll see matrices and arrays everywhere. But if your data is more like tables in Excel, with mixed data types and labeled rows and columns, then data frames, which we will be covering in the next episode, are usually the better choice. And speaking of data frames, one quick clarification before we move on. Let's take a moment to understand the difference between a matrix and a data frame, as this can be confusing at first. If you're new to R and don't know what data frames are, here is a quick explanation. A data frame is a data structure where data is arranged in rows and columns, much like a table, and we are going to be learning more about what they are and how they work in our next episode. So what sets data frames apart from matrices? Well, while matrices are ideal for mathematical computations, that is best for calculations and linear algebra, they require all elements to be of the same data type. In contrast, data frames are more flexible. As you can see, here is a name data type, that is a character string, here is a numeric data type, that is age, and here is a logical data type, that is true and false, which is stored in student. So this allows each column to have a different type of data. This is why real-world data sets, which often include information like names, which are characters, age, which are numbers, and student flags, which are logical values, are usually stored in a data frame rather than matrices. So we'll be covering more about data frames in our next episode. And before we move on to our outro, let's have a quick summary slide of what we learned today. Today, we learned about matrices, how matrices store data in rows and columns, and they contain one data type. How to create a matrix with this, which is a number notation which includes number from 1 to 6, and the number of rows to include, and how we can arrange numbers by row. We also talked about indexing the elements in a matrix, which is by the row and column format, how matrix operations work, including add, multiplication, and matrix multiplication, and what an array is, and how you can conceptualize an array. And that is about it for episode 7. You now understand vectors, lists, and matrices, which means you are only a step away from the most important structure in R, and that is data frames. Like I discussed before, that is where real-world datasets live. In episode 8, we connect everything that you have learned so far into tabular data and start working like analysts. So I hope you tune in for episode 8. If you found this video helpful or liked the video, please drop a like and subscribe to our channel for more such videos. And until our next video on data frames, bye bye and happy coding. Hey everyone, and welcome back to our R Programming for Beginners series. Now, in our last episode, we talked about what matrices and arrays are and how we can work with them inside of R. And inside today's episode, we step into one of the most important structures in R, that is data frames. You will work with them in nearly every R project, especially when handling real-world tabular data, such as sales records, survey results, or temperature readings. So, without further ado, let's get to discussing about them now, shall we? And before we move on with the video, a quick shout out to the R Programming Learn and Code app from Codin inside the Google Play Store. With this app, you can learn R right from your phone, anytime and anywhere. And there are engaging and interactive courses on the app that make learning fun. And with quick facts and quizzes inside each course, you'll be truly understanding R and not just memorizing it. It also has an R compiler which allows you to type and test any bits of R code that you want. So, if you want to learn R and are looking for somewhere to start, do check out the R programming app from Codin inside the Google Play Store. Now let's move on with the video. What is a data frame? A data frame is like a table. It has columns and rows. Similar to an Excel sheet or Google sheet. Each row represents an observation or an entry. So this row, which is the first row, Alex, 21, 170 and true, represents the data of one person. The person's name is Alex, his age is 21, his height is 170 centimeters, and he is a student. So rows represent an entry or an individual case, whereas columns represents the type of data. This is one attribute. This is a column which contains data of height, so it is one attribute. So now that you have a general idea about what a data frame is, let's get to talking about the characteristics of a data frame. Now inside a data frame, each column can contain a different type of data. It can contain numbers, it can contain characters, or it can contain logical values as well. So inside this data frame as well, this is a numeric data, age is a numeric data, name is character data, and whether the student passed or not, that is passed, is a logical data which has true and false values. So this combination of different data types inside a single data structure is what makes data frames so flexible and widely used. And now that we understand the concept of data frames visually, let's know about how we can create data frames, and later we'll create an actual data frame inside our R compiler as well. So in order to create a data frame, you will have to use this right here, this method, data.frame. And inside it, you'll have to store the name of the column and equals the values that you want to store inside it. So the name column will contain Ayush, Riya, and Sam. And likewise, age will contain 21, 22, 20, and so on. So here, I'm creating a simple data frame called students, and inside students, each column is created with the help of vectors. So C, which is a combined function used to create vectors, stores Ayush, Riya, and Sam, and it is inside the name column. So our data frame will look somewhat like this. The name will contain names, the age will contain 21, 22, and 20, and remember all of these are in order. So Ayush will have an age of 21, a height of 5.8, and a student value, that is student, true. So these are all in order, and so are the columns. And now that we know the concept about creating a data frame, let's actually create a data frame inside of our R compiler. So inside Codin.com's compiler section, let me head over to R compiler and then try to create a data frame. So in order to create a data frame, first I'll have to define the name of the data frame. So as our example was, okay, let me first of all increase the size for you so that you can see well. So inside our example, it was students, and then an arrow symbol to actually store the data frame. So data.frame, and inside this I will write the individual column names. So first of all, we will have the name column, and inside this we will have a collection, that is the combine function, and it will store a vector, that is a collection of values of names. So first of all, let's say our first name is Ayush, and then our second name is Riya, and then our third name is Sam. After that, we are done with this column. So we'll enter a comma and then move on to another column, that will be age. And this will also store a vector, which by the way is just a collection of values. If you don't know what vectors are, this combine function will store a collection of values, and that is basically what a vector is. So oops, not a string value. The age will be 21. So let's say Ayush's age is 21. Remember, all of this is in order. So Riya's age will be 22, and then Sam's age will be 20. After that, comma, and then the height, and then once again another vector. This will store numeric values as well. 5.8, Ayush's height is 5.8. Let's say Riya's height is 5.4, and Sam's height is 5.9. After that, finally, let's create a table called isStudent. So instead of isStudent, let's just create a student column, and this will hold a collection or a vector of boolean values or logical values. So true, let's say let's say Sam is not a student, so false. And that is it for our data frame. Now in order to actually view how this data frame is, let's print it out. So we'll print out, okay, my bad, caps lock is on, students, and we'll run. So you can see that this is the index, and 1 2 3, meaning there are 3 rows. The name table has Ayush, Riya, and Sam. Age has 21, 22, 20, and so on. Height has the heights, and the student has the logical values. So this is how you create a data frame inside of R. And now that we know how to create a data frame, let's talk about accessing the values of this data frame. So after discussing about how we can actually create a data frame, let's talk about how we can access column values, or let's say how we can access specific values of a data frame column. First of all, to access a column inside a data frame, we use the dollar symbol. It's like asking R, give me just the name column, or give me only the age values or student values. So inside of our code, if we did students, $, and then name, it would give us the name column. Likewise, students, $age gives us the age column, and students, $student would give us the is student column of logical values. So like I said before, it's like just asking R to give us the name column. So let's practically fetch our name columns, and a bonus point, fetch specific values inside of a specific column. So if I wanted to fetch Riya, let's see how we can do that inside of our R compiler. So once again, let me first access the entire column of age. In order to do that, I would have to do students, and remember, $, and then age. And if I did that, it would output us the age values, that is 21, 22, and 20. And remember, this is a vector of age values. Now if I wanted to access a specific age called 22, let's say, how would I do that? Well, a hint that I gave before, I told that this is a vector as well. So vector indexing works inside a data frame. So if I wanted to get 22, which is the second value inside of this vector, I would have to just mention its index. So in order to get that, I would do student $age, but inside of the age vector, I would want the second value. So I would just type out a pair of square brackets and then mention 2. Now this would give us, the second value, that is 22. Likewise, if I wanted to first of all access the, let's say, names, so I would do students, $, and then the name of the column, name. And if I wanted to access a specific name, let's say Sam, which is in the third index, I would just do name first of all. This is the column, and to access a specific value, I would do 3, its index. So this would give us Sam. Now let's run this. And first of all, this line gives us Ayush, Riya, and Sam, the names of the name column, the entire column, and then mentioning its index would give us the specific value. It gives us Sam, since Sam is in the third index of the name column. And I hope that is clear for you guys. And then another way that you can achieve this is by entirely skipping the $sign rule. So if I just did students, which is the name of the data frame, and then square brackets, and let's see, this Sam value is in the third row and in the name column. So first of all, you mention the row, that is 3, it is in the third row, and then the column name which this value is in. It is in the third row and it is in the name column. So I would just have to write a pair of quotes and then name. Now this would output the same value. So Sam. Now let's say I wanted to access Ayush. So in order to do that, it is in the name column, but it is in the first row. So I would have to first of all change the index value of the row to 1. Now this would output us Ayush. So I hope that is clear for you guys. And that was how you can access specific columns and specific values inside those columns. And I hope you understand that well. Now let's move on to a topic of adding or removing columns. So for now, our initial data frame only has 4 columns. They are name, age, height, and student. But what if I wanted to add another value? and we'll look into just that. First of all, let's look at theory, and then we will do it practically inside this compiler. Now, in order to add or remove columns, let's first talk about adding columns inside of our data frame. It's pretty simple. So if I wanted to add a new column inside of our data frame, I would just mention the name of the data frame, then mention the $sign, and then I would want to write the name of the new column that I'm adding. So let's say I'm adding a logical column, that is whether the student passed or not. So I would write the name of the data frame, $sign, and then the column name. And inside the column, I would just store another vector. And remember that these values of the new column should be equal to the values of the previous column. So if there are 3 values, or let's say 3 rows inside of the previous column, there should be 3 values inside of the column that you're adding. Whereas inside removing columns, you would just mention the name of the column. So inside students data frame, let's say I wanted to remove height, the height column. I would just mention that students data frame, $sign, then the height column, and then set its value to null. This will delete the height column. So let's see. First of all, if I wanted to add a new value, I would just mention that value after the $sign, after the, let's say, data frame, and then the $sign, and that would add the column. So if I do students $sign passed, it will add the student's value. And this is what I meant by the number of values should be equal to the previous data frame. So let's see. Each column inside of our previous data frame had 3 values, right? So when adding a new column, we need to mention 3 values as well. Otherwise, it will give us an error. And whereas if you wanted to remove a column, let's say I wanted to remove this height column, then I would just mention the height column, that is students $sign height, and then set its value to null. That would remove the height column entirely. Now we do know the theory about this, and we have discussed the theory. So let's do this practically inside of our compiler. So once again, I'm inside of our compiler. Now let's remove, or let's say let's comment these values. Let's actually not comment the first value, since we need to know what our data frame looks like before. So for now, our data frame has 4 columns, and let's add another column to our data frame. So before we do that, let's just decrease the font size so that it looks more clear. So to actually add the name of our column, we'll just mention the name of the data frame, that is students, and then add a $sign, and then the name of the column that we want to add. So in our case, it is past. We want to add the past column, and let's mention the content of the column. So a vector, and it will contain first of all true, and then false, and then true. So it should have 3 values in order to actually add the column. Now let's run this, and let's print out the students data frame once again. So you can now see that the past column is added onto our data frame. And now let's finally remove a column. So in our example, we looked at removing height, so we'll remove height as well. So okay, let me just delete this bit of code, and then we will remove height. So once again, to remove height, we will have to mention the name of the data frame, the name of the column that we want to remove, that is height, and then set its value to null. Now this will remove the height column. So it's students. Okay, once again, sorry for my spelling, students. If we print out students, we'll be able to observe that the height column has been removed. So that is how you deal with adding and removing columns inside R. Now, after talking about adding and removing columns from a data frame, let's discuss about inspecting a data frame, which is a very important topic. Because whenever you load or receive a new dataset, the first thing you do is inspect it. So let's take a look at some of the methods or functions that help us in inspecting a data frame. First of all, we have the head function. This function lets us preview the first few rows of the data frame. Next up, end row and end col. It tells us the size of the data. That is, end row shows us the number of rows, and end col, that is end column, shows us the number of columns inside of the data frame. And finally, str, that is structure, helps us to understand the structure of the data frame. So let's preview some of these. So let's look at some of these methods inside of our compiler. Okay, now that we are inside of our R compiler, let's try to use some of the methods. So head would give us the first few rows of the student's data frame. But in our case, since it only has 3 rows, it will just return those 3 rows. So by default, the head function inside of R returns the first 6 rows of the data frame. But you can change the number of rows printed, or let's say returned, by the head function by mentioning a new parameter called n. If you type out n equals 10, it would give you 10 number of rows. Okay, in order to show how the head function actually works, I will have a data frame which has more than 6 number of rows. So here we have a data frame which has exactly 10 rows, and the columns are name, age, and score. So let's see what head function would do on the student's data frame. When we run this, you'll be able to see that it gives us the first 6 rows, that is Arav to Nisha, and then, well, 1 to 6. So this is what head does. But if you want a custom number of rows returned by the head function, you can just mention n equals, let's say I want 9 rows, and I'll run, and you can see that it returns us 9 rows of the student's data frame. So that is how head works. Now next up, let's look at another function that helps us in inspecting a data frame. Now, as I mentioned, the number of rows in this data frame is 10. So let's see what n row results in when I do n row, a pair of parentheses, and then students. Now when I do this, it will return us 10, meaning that there are 10 rows inside this data frame. And let's see how many columns are there. Well, we can clearly see that there are 3 columns, name, age, and score. But what will n col return? So n column and then students. So 3 columns. And then finally, let's view the structure of students. So str and then students. Let me comment these as we know how they work already, and then run this. So you can see that it gives us a brief detail of the structures of the data frame, that is students. It says that it is a data frame, students is a data frame of 10 objects of 3 variables. So there are 10 rows of 3 variables which are name, age, and score. So it says 10 objects of 3 variables. The variables are name, age, and score, and well, the objects are these objects, that is each individual row data. So I hope you understand how all of these inspection functions work. Now let's head over to a quick summary. So as a summary of today's topics, let's see what we learned today. Today we learned what a data frame is. We learned that a data frame is a table of rows plus columns. And then we learned that columns can have different types of data. And we learned how to create a data frame using data.frame inside of our R compiler. We learned that we can access the values of the data frame using a $sign, may it be columns or individual data inside those columns. And next, we learned how to inspect the data frame using functions like head, n row, and column, and str. So that was it for this video. Great work making it this far. Data frames are everywhere in R, and getting comfortable with them now will make your journey much smoother later. In the next episode, we're taking it a step back and discussing about what operators are and how they work inside R. So hope you tune in for that. If you liked this video or found the video helpful, please drop a like and subscribe to the channel for more such videos. And until the next video, bye bye and happy coding. Hey guys, welcome back to another video of the R Programming for Beginners series. Now in the last episode, we talked in detail about what data frames are and how we can work with them inside of the R programming language. And in today's episode, we're taking a step into another topic, that is operators in R. So let's get started with the video. Now before we start coding, we need to understand what operators actually are. Well, operators are symbols. Symbols that allow us to perform actions. Actions like adding numbers, subtracting numbers, comparing values and seeing if values are greater than one another, and also checking logic. You can think of them like verbs of programming. That is, if you add operators with values, you'll get some results. Okay, now that we have a basic idea about what operators are, let's look into the types of operators in R. In R, operators mainly come in 3 groups: arithmetic operators, comparison operators, and logical operators. We'll learn about them one by one and then apply them to real data. Well, before we work with operators physically inside of our compiler, let's know that operators return results. Operators don't just sit there. They take values, they perform an action, and then they return an answer, often true or false values. Now this becomes important when we filter data and make decisions later. So example is a comparison operator is being used right here, that is 5 is greater than 3. This will return a true value. And an arithmetic operator, that is the plus, or let's say the addition operator, will return a value of 2 plus 2, which will be 4. And not only single number values, but R operators work with vectors as well. Since R is vector based, operators don't only work on single numbers, they apply to entire sets of vectors automatically. So adding one vector to another would give us the following result. And when using operators on vectors, they add, or let's say perform operations with the corresponding values. That is, 1 will be added to 4 and produce 5, 2 will be added to 5 because they are both in the second position of each vector, and it will give us a result of 7, and 3 will be added to 6 and give us a result of 9. Okay, now that we have discussed about the theory regarding operators in R, let's actually have a practical coding demonstration inside of our R compiler. Okay, so we are inside of our R compiler. So first let me increase the font size for you guys so that you can see this clearly. So first of all, we'll use a bunch of arithmetic operators. So let's say arithmetic operators, and then we will first of all do addition, so 5 plus 3, then subtraction, 10 minus 4, and multiplication, which is symbolized by 6 times 2, and then division, 8 by 2, and then power, so 2 to the power of 3, and then a modulus operator, which is 10, and then 2 percentage signs, 3. Now I'm sure you're familiar with all of this, but you guys might have some confusion in this modulus operator right here. But before we explain what this does, let's actually see the output of using these operators. So as expected, all of these operators will do their assigned function, that is addition will perform addition, 10 minus 4 is 6, so subtraction, 6 times 2 is 12, 8 by 2 is 4, and 2 to the power of 3 is 8. But what is this 1? Why is 10 modulus 3 returning 1? Well, using a modulus operator, that is these 2 percentage signs, returns you the remainder of a division. So remainder of the division. Now let's say here is 11. We know that 3 times 3 is 9, and the next multiple of 3 is directly 12. So the quotient of 11 by 3 will return actually 3. But there is still a remainder of 2. So 11 modulus 3 will give us 2. So you can see that clearly. Now if I do 10 and then 2, what do you think will happen? Well, since 10 is perfectly divisible by 2, it will leave no remainder. Hence, 10 modulus 2 will return a value of 0. So you can see that clearly. But when I do 11, once again, it will return 1, since 1 is the remainder of 11 divided by 2. So I hope the modulus operator and all of these arithmetic operators are clear to you guys. Now after the arithmetic operators, we will be working with a bunch of comparison operators. So let's comment all of this, and then we'll be moving on to, okay, let's actually remove all of this, and then we will be moving on to comparison operators. So comparison operators. And as for comparison operators, we'll be looking at 4 to 5 comparison operators. First, we have if comparing two values are equal or not. So when I do 5 equals to a double equals to 5, it should compare the values. Now remember that 5 single equals to 5 is a assignment operator. Now I know that traditional values assign, let's say if we had a variable called x, we would traditionally assign the value of 5 to x with the arrow symbol, but you can also do it with an equals to sign. So it is important that when you compare values, you use 2 equals to signs, because this is actually the comparison operator for equals to. So in this case, we are comparing if 5 is equal to 5. Now this should obviously return us 2 since 5 is equal to 5, but let's say if I do 5 plus 2 is equals to 4 plus 3, this should also return us a true value, since 5 plus 2 is also 7 and 4 plus 3 is also 7. But what if we did 4 plus 2? Now this is 6 and this is 7. 6, 7. But what if we do this? So since this is 7, or let's say this is 6 and this is 7, it will give us a false value. Now I hope the comparison operator is clear to you guys. And after that, what we will do is we will compare if a value is not equal to the other value. So the symbol for not equals to is first of all not, which is an exclamation mark, and then equals to. So in this case, we are looking if 3 is not equal to 4. Now this statement is actually true. 3 is not equal to 4. So this will give us a true value. So true. But if we put there 3, this statement says that 3 is not equal to 3, which is false. So this will give us a false value. Now after that, we have the greater than and lesser than value. So these are pretty simple. It will just compare if 7 is greater than 10, which is false, so it will return a false value. And if we flip the sign and turn it to lesser than, it will give us a true value. And once again, we have lesser than or equals to. Now this is a bit different. Now this also checks if 7 is equal to 10, which is still true, since 7 is less than true, although it is not equal to 10, but it is less than 10. But if we did 7 is less than or equal to 7, this will still give us true, since 7 is equal to 7. So I hope you understand that clearly. Now comparison operators check relationships and return true and false values, as you have observed. So this will be the foundation of filtering data and if-else logic later. Now that we know about comparison operators, let's move on to logical operators as well. So logical operators. So when talking about logical operators in R, there are two types of operators. One is the element wise logical operators, and then next is just the default logical operators. So what are the element wise logical operators? Well, the element wise logical operators are two symbols. One is the ampersand symbol, so the ampersand symbol, and then the pipe symbol. So these are the logical and, or let's say the element wise logical and element wise logical or. And then there are the logical operators, which are double ampersand symbols and then double pipe symbols. Well, these are logical operators in general. Now beginners might wonder what is the difference between these two. Now these both operators compare logical values, but there is a twist. Now as the name suggests, when using element wise logical operators, R compares values element wise, which is position by position. Now let me demonstrate what this means. So let me first of all cut all of this, and let's say we have two vectors. First of all, the vector x, which contains three values. So true first of all, false, and then true once again. And let's say we have another vector, but this time it is y, and then y has of the value of true, and then false. Okay, meant to type false. And now let's use the logical operator, that is ampersand y. Now when using ampersand operator y, this compares the values. Now for this to return a true, okay, let's just say that logical operators return a true or a false value. Now for this to return a true value, first of all, when using AND operators, whether it is the element wise operator or just the logical operators, that is double ampersand symbol, first of all, this will return true only when both of the values are true. So only true and true will return a true value. So in our case, when we use x and y and make it run, you will see that it returns a true, false, and false value. Now I will say why this is so. Now like I said before, it compares values position by position. Now first of all, the first position, first value is true, and inside y2, the first position value is true. So true and true give us a true value. But in our second position, x has false, whereas y has true. So false and true value give us a false value. Now in order to give us a true value, both of these should have been true, like our first example. And so with this, even though x has a true value, y has a false value inside the third position, so our third position is a false value. See how it returned us a vector when comparing values between x and y. That is how the element-wise logical operators work. Now this is the AND operator. Now let's see what x and then OR y gives us. Now when doing this, you can see that all of these are true. Since for a logical OR operator to return a true value, only one of the values that are in the comparison have to be true. So it will only return a false value when both of these are false. So when we do false false and run it, we can see that it provides us a false value. Since both of these are false, OR operator returns false. Now let's have a realistic numeric example instead of just true and false values. Let's say we have still a vector called numbers, and let's say the numbers vector has the values of, first of all, -2, 3, 8, and then 15. Now let's say we have to compare numbers. So when I do numbers greater than 0, what this will do is tell us if all of these values are greater than 0 or not. So when we run this, it will return us false, true, true, true. Since only -2 is not greater than 0, it returns us false and everything is returned true. In a similar way, when we do less than 0, or let's say less than 10, all of the initial values will return true since all of these values are less than 10, but 15 is not less than 10, so it will return false. Now, what if we want to combine both of these conditions? That is where the logical operator comes in. So, inside of our code, when we do numbers is more than 0 and numbers is less than 10, this AND operator, or let's say the ampersand operator, will check both of these conditions and will only return a true value if both of these conditions return true. So for each of these number, our AND operator will only return true when the number is both greater than 0 and less than 10. So let's run. And we can see that only 3 and 8 return a true value since these are both greater than 0, 3 is greater than 0 and 3 is less than 10 as well. So this AND operator, or let's say the ampersand operator, returns a true value. Now, what would happen if I use a logical OR operator? Now for this question, I want you guys to drop your answers in the comments below. If you're watching this video and interacting, I want you guys to answer this. This is quite simple and you might already know the answer. So I hope you guys answer this in the comments below. Okay, now that we have talked about the element-wise logical operators, let's talk about logical operators in general. Once again, I have the two previous vectors, that is x and y, which both hold true and false values. Now instead of using x ampersand and then y, let's use two values because this was the element-wise operator, and let's use the actual logical operator. And let's see what happens. First of all, this should be a small x, and then it would give us an error. Error in x and y, length equals 3 in quotient to logical 1. So this might give you a hint, but the logical operator, that is two ampersand values, only work for single values. So instead of a vector, we only get one true or false. So in our case, we should first of all use 1 in order to access this true value and then compare these two values. So true and true should return true, and let's say both, let's compare, okay, this should be, let's say this is true. So let's compare x2 and then y2 as well. So first of all, this false value and true value, and let's see, it will return false. And same with the OR value. When we use two pipe symbols, it will perform operations with a single value instead of the whole vector. So it will give us true since at least one value is true. Let's turn this to false and let's observe. It should return false. So by this, it should be clear that the logical operators, the general logical operators, that is two symbols, only work with single values. And that is why it is used only for decision making and not data processing. So I know I have not discussed about this inside of our series yet, but this is used inside of our if-else conditions, which are control statements. So I'll give a little demonstration. So let's say we have two numbers. So one is A and two is B. So 2. Now let's compare these values. If A is greater than 0, logical AND, so two ANDs, since we are working with single values, and B is greater than 0, let's say we will print that both the numbers are positive. Now let's run this. So both the numbers are positive is printed because this is true. A is greater than 0 and B is greater than 0. So I just meant to demonstrate that these kind of values are used inside of conditional statements like if-else statement. If a condition is true, execute this line of code. In those case scenarios, these logical operators are used. Whereas when processing data like vectors and comparing values inside vectors, we use the element-wise operators, which are just the single ampersand value and the single pipe value. So I hope that is clear for you guys. This compares a single value, whereas these can be used to compare multiple values and return all of them inside of a vector at once. So after this, let's head towards a quick summary. Okay, and as a recap of today's topics, we learned about arithmetic operators, comparison operators, logical operators, and that these operators work on vectors as well. So that was it for this episode. In the next episode, we're going to be dealing with conditional statements, as we discussed earlier, a teaser of the conditional statement, which was the if statement. That is, if a condition is true, you can execute a line or a bunch of lines of code. We'll be talking more about that. So don't forget to tune in. And if you liked the video or found the video helpful, please drop a like and subscribe to our channel for more such videos. And until the next video, bye bye and happy coding. Hey everyone, and welcome back to another episode of the R Programming for Beginners series. Now, so far in this series, we have been using R to calculate values, to store data in different types of data structures like vectors, lists, matrices, and data frames, and we have been using those data structures to perform different operations. Now, we have been doing all of that, but up until now, everything that we have done runs line by line. That is, the program runs without thinking and without taking any decisions. And in today's episode, we are going to discuss about something that allows R to make those decisions. So in today's episode, we are going to be discussing about control statements, or let's say conditional statements in R. Conditional statements help R react differently depending upon a situation. So in order to discuss about them, without further ado, let's get started with the video. So like in every other video, let's have a basic introduction first. What is a conditional statement? Or let's say, what are conditionals? Well, conditional statements are statements that execute different tasks based on whether a given condition is true or false. So if we have a condition, depending on whether that condition is true or false, a conditional statement can tell R what action to perform. Let's say we have a condition. If that condition is true, the conditional statement can tell R to take path A, whereas if it is false, the conditional statement can tell R to take path B. So that is what conditional statements are. And now that we have the basic knowledge about what conditional statements are, let's learn more about them by knowing what core conditional keywords are there in R. So R gives us a few simple keywords to handle decisions. And among them, if statement is the most basic. It runs code only when a condition is true. That is, if a condition is true, it will run some code. Next up, we have the if-else statement, which adds a second option for when a condition is false. So it helps us choose between two outcomes. That is, if a condition is true or if a condition is false. Next up, we also have the else if, which helps us to check several conditions one by one. And finally, we have the nested if condition, which allows more detailed decision making inside another condition. So inside an existing condition, we can hide another condition. And if you are confused about some of these keywords, you don't have to worry at all. That's because we'll see the examples of all of these step by step later on in the video. So before we get into coding, let's understand the logic behind conditional statements. Every conditional statement in R comes down to one simple question. That is this condition true or false? And R does not guess. It evaluates the condition, gets either true or false values, and then decides what to do. If the condition is true, the code inside the code block will run. That is, the code will execute. And if it is false, the code is skipped. Or R moves to another option like the else block. So this is the basic logic behind it. And now that we know the basic logic, let's look at the syntax of the if, else if, and else block. So this is the basic knowledge that you require in order to know about conditional statements. That is, first we will have the if keyword as discussed before, and inside a pair of parentheses there will be a condition. We'll have to check if this condition is true or false, and if this condition is true, the code inside this code block, which is defined by this pair of curly braces, that is this curly brace and this curly brace, will enclose a block of code, and if this condition is true, this block of code will execute. But what if this condition is false? Well, if you have an else if block, we can add another condition that we would want to check. So else if another condition is true, execute this code block that is defined by these curly braces. And we can keep adding else if blocks to add condition after condition, and after all of the checks are finished, if none of these conditions are true, we will have to execute the else block. After we define the else block with the else keyword and a pair of curly braces, we can add code to be executed if none of the conditions above match. So that is the gist of it. We have the if keyword. If condition is true, execute this. Else if this condition is false and this condition is true, execute this code block. And if none of these conditions are true, execute this code block. So that is how the if, else if, and else structure work. So now that we know about the syntax, let's get into our compiler and start coding, shall we? So now that we are inside of the R compiler of coding.com, let's first of all execute the basic if statement. So in order to demonstrate how an if statement works, I'll first of all create a variable x and then store a value of 10 inside of the variable x. And then after that, we will define our condition. That is with the if keyword and a pair of parentheses, if, and then inside of our parentheses, we will have the condition to be defined. So if x is greater than 5, and then a pair of curly braces, and inside this pair of curly braces, we will have to define the code block that we want to execute, or let's say we want R to execute when this condition is true. So if x is greater than 5, let's print something out. If x is greater than 5, print that small x is greater than 5. Now what will happen is when we run this program and this condition inside of the parentheses is true, R will execute this block of code defined after the if statement. So in our case, it should print out x is greater than 5. So this is it. So let's say our x value is 4 and we run our program, nothing would happen and this code block would be skipped entirely because this condition is not true at all. X is not greater than 5. So that is the basic if statement for you guys. Now for the if else statement. Let's say we want the program to at least output something, right? We can't just output nothing. So we would add a else block. And an else block comes in handy when you want at least something to be outputted whenever the condition is false. So if this condition is true, this will be outputted, but when the condition is false, that is else, let's say print and then a pair of parentheses, x is smaller than 5. So if our condition is true, this block will execute, else this block will execute, that is this code block right here. So since our value is lesser than 5, that is this condition is not true, our else block will execute and it will execute this block of code. That is, it will print out x is smaller than 5. So that is how the basic if else statement works. Now let's have a practical example. Let's say we have to define a condition for a person to vote. That is, we will first of all, let's say the age of the person is 16 and we have to define a condition. Let's say the person can only vote if his or her age is greater than or equal to 18. So if your age is greater than or equal to 18, what would happen? We'll print out you can, okay, you can vote. Else, we will have to print out you are too young to vote. So in this case, what would be outputted? Since this condition is not true, that is, our age is not greater than or equal to 18, in fact it is less than 18, this else block would execute, as you can see. But if this age were to be 20, this condition would be true. That is, our age is greater than or equal to 18. That is, 20 is greater than 18. So this block would execute. It will print out you can vote. And that is how the if else block works. Now, what if you want to add multiple condition checks? That is where the else if block comes in. Else if. So let's remove this example entirely. And let's say we want to check the score of a student and grade that student based on the score. So first of all, we will define the score variable, and let's say the student has a score of 72. Now inside of our condition, first of all, let's check if our student is eligible for an A grade. So if score is greater than or equal to 90, the student will obtain a grade of A. So let's say we will print out grade is A. Now what if the student gets a score of below 90? We want to define a condition for that as well. So else if the score is greater than or equal to 75, we will define another code block to execute if this condition is true. That is, if our score is greater than or equal to 75, let's say the student will get a grade of B. That is another condition. And let's say we want to add yet another condition, that is C grade. So else if the score is greater than or equal to 50, let's say the student will get a grade of C. So the grade will be C. And if none of these conditions are true, that is, if the score is not above or equal to 90, above or equal to 75, or above or equal to 50, that is, none of these conditions are true, finally we will define an else block to execute if none of the conditions are true. That is, let's say the student fails. So print grade F. Now what will happen when we click on run? First of all, we will see that the score of 72 will be stored in the value of score, or the variable of score. And first of all, our R program will try to check for the first condition. Thus, it will check if the score is greater than or equal to 90. And since it is not greater than or equal to 90, it moves on over to the second check, that is this else if block. It will check after this check of more than or equal to 90, our R program will check if the score is greater than or equal to 75. In our case, that is not true as well. So it will once again move over to the third check, that is the third, or let's say the second else if block. And since our score is greater than or equal to 50, this block of code which corresponds to this condition will execute. So it will print out C. Now let's say our score is 40. Now since none of these conditions are true, that is score is 40, so none of these conditions, that is 50, 75, 90 are true, our else block will run, since none of these conditions are true. If none of the conditions that we defined up are true, our program will fall back to the else block. So it will print the grade is F. So that is the basic gist of if, else if, and else. So just a quick reminder, R starts checking conditions from the top to bottom. So it starts checking condition from the top and gradually moves towards the bottom. So if it finds that a condition is true, so let's say our score is 90, it will stop checking the condition as soon as it finds one condition to be true. That is, if our first condition is true, R will not even check all of these conditions. Since our first condition is already true, it will execute this block of code and skip all of this entire rest of the block, or let's say rest of the else if and else conditions entirely. So in our case, once it finds out that the score is equal to 90, it will execute this immediately and then skip the rest of the code blocks. and that is why the order of the conditions matter. So let's say I say score is greater than or equal to 75. That is, I check that the score is greater than or equal to 75. If our score is greater than or equal to 75, we'll get a B grade, and if our score is greater than or equal to 90, we will get an A grade. Now, even though we have gotten a 90, R will check this condition first, since we have defined this if block first, and then it will give us a score of B. Because as soon as it finds a true condition, because 90 is greater than or equal to 75, it will give us the value inside of this code block. So even if we have 90, our grade will still be B. So that is why the order that you define these conditions will matter. We want to properly prioritize our conditions in order to avoid this error. So in our case, we have defined, first of all, the check for A grade first, since we want to know if the student has gotten an A grade or not. So now that we know about the if, else if, and else pattern, let's move towards the final topic of our video, which is nested if statements. So nested if statements. And this basically means if statements inside if statements. So I'll explain to you guys what this means with a simple example. Let's say we have a variable called number, and this holds a value of 12. Let's first of all check if this number is greater than 0, that is, if this number is positive, and if this number is positive, let's check if this number is even. So if, first of all, this is our first condition, if our number is greater than 0, that is, if our number is positive, let's print out that this is a positive number. So print positive number. So after we know that our number is positive, let's also check if our number is even. So inside of this code block of the if statement, let's define another if statement. If our number is perfectly divisible by 2, so if you remember from our previous episode of operators, this is the modulus operator, which checks the remainder of our number divided by 2. So if our number divided by 2 leaves no remainder, that is, our remainder is 0, we can safely say that our number is even. So print and it is even. So what did we do? First of all, we checked if our number is positive or not, that is, if our number is 0. And after we checked if our number is 0, let's say after we confirmed that our number is 0, we also checked if our number is even or not. That is, we nested this if condition inside of this if condition. And that is what nested if statements mean. You use one condition inside another condition. That is, you double check conditions, basically. So let's run this, and we will find that it is a positive number and it is even. Now what if we type out 11? Now this will obviously be true, so it will print out positive number, but this condition, that is our 11 divided by 2, will not leave a remainder of 0. This condition won't execute. So it will only print out positive number. And that is how if statement, or let's say nested if statements, work. You define one condition inside another condition. So that was it for this video. Let's have a quick recap of our slides. So as a recap of today's topics, today we learned about all of these concepts. That is, we learned about the if statement, which executes code only when the condition is true. Next up, we learned about the if else statement, which provides two possible outcomes based on the condition. So that is, when the condition is true, it will execute the if block, and when the condition is false, it will execute the else block. And after that, we also learned about the else if condition, or let's say the else if statement, which tests multiple conditions in a sequence. And finally, we also learned about the nested if statement, which handles complex and multi-level decision logic. So I hope all of these concepts were clear to you guys. And next up, we will be working with loops inside of R. So don't forget to tune in. If you liked this video or found this video helpful, please drop a like and subscribe to our channel for more such videos. And until the next episode, bye bye and happy coding. Hey everyone, and welcome back to the 11th episode of our R Programming for Beginners series. Now in the last episode, we talked about conditional statements and how they allow R to take decisions based on a condition. And today, we are dealing with another aspect of R programming that controls the flow of the program. And they are loops inside of R. Loops help us in repeating tasks automatically instead of manually. Thus, they are a big help when it comes to repetitive tasks. So, without further ado, let's get to knowing about loops in R now, shall we? So, first of all, let's understand what a loop is. So, what are loops? A loop is a way to repeat tasks over and over again without typing the same line again and again. Now, what would you do if you wanted to print something 10 times in a row? If you have no knowledge about loops, you might think of writing the same print statement 10 times, which does work, but it is tedious and inefficient. Instead of writing 10 print commands, we can use a loop inside of R, and R does the repetition for us. So once the loop starts, it repeats tasks over and over again. So it repeat tasks until a condition is met or until we stop the loop. Okay, now that we have a basic idea about what loops are, let's get to knowing about the types of loops inside of R. So there are 3 types of loops inside of R, and each loop repeats code, but the reason for repeating is different. First of all, we have the for loop, and this loop is used when the number of repetitions are countable. Next up, we have a while loop, which repeats something while a condition is true. That is, while loops repeat themselves until a condition becomes false. And then finally, we have the repeat loop, which runs indefinitely until we stop it manually. And like I said, all of these loops repeat code, but each repeats for a different reason. Now we'll break each one of these loops down one by one later on in the video with syntax and examples. But before we start working with them, let's get to know about loop control, since we will be needing these when we work with loops. So loops are powerful, but sometimes we need to skip or stop certain repetitions of the loops. That's where 2 of the keywords that help in loop control come in handy. First of all, let's say we want to stop a loop after a repetition. So an iteration is just a repetition. So if the loop has already repeated 3 times and is going to run again, that will be the 4th repetition or the 4th iteration. So let's say we want to stop a loop after the first iteration. That is, after the loop has run 1 time, we want to stop it for some reason. Well, that's where the break statement comes in. And this is one of the tools that we will be using in loop control. If we want to stop the loop after a certain number of repetitions, we can use the break statement and it will stop the loop for us. So a break statement completely stops the loop. And after the break statement, we have something what's called the next statement. And what this does is it skips the repetition that it is used inside of and moves over to the next repetition. So let's say we have repeated a loop 1 time, and during the next iteration we want to skip it. So when the next statement is used, it skips the second iteration, that is the second running of the loop, and directly moves on towards the 3rd iteration. So that is what it does. It skips 1 iteration and continues to the next, hence the next keyword. So these keywords are used in order to control loops. And I know the theory might sound a bit confusing, but we will be using these practically inside our practical demonstration, which is going to happen right now. Okay guys, now I'm inside of the code in R compiler, and first of all I'm going to demonstrate to you guys how do you use the for loop. So the syntax for loop is, first you have to use the for keyword, and then inside of the for keyword and inside of these parentheses, you will have to use a variable to use inside of your loop. So first of all, we'll create the looping body, which is symbolized by these curly braces, and then inside of the for loop parentheses, we will create a variable I. Now this is also called a looping variable because this will be used inside of our loop. So we'll define for I in a range of values from 1 to 5. So inside each loop, I will first so inside the first loop, I will first have the value of 1. Then after this loop is over, so let's say inside of our loop body, we say we want to print the value of I. So inside of a for loop, what happens is when you iterate through a range of numbers by using the in keyword, so for I in a range of numbers from 1 to 5, first of all, I will have the value of 1. And then it will after it prints the value of 1, it will loop over, and inside the next repetition, or let's say inside the next iteration, I will move on to the value of 2. So first of all, I inside the first iteration, so first, okay, my bad, that was meant to be a hashtag. So inside the first iteration, so let's say repetition to make it easier, I will equal to 1, and then in the second repetition, I will equal to 2. So that is how for loop works. So when I click on run, it will first print out 1, then the loop will be over and the value of I will move from 1 to the value of 2, and likewise of all of the way until 5. After it prints 2, I will update to the value of 3, it will print out 3, print 3, and then after that I will update the value to 4 and it will print 4 because I value will be 4, and all the way up until 5. And if I did 10, it would print values upon all of the way up to 10. So that is basically how a for loop works. The variable I automatically takes each value in this sequence one by one, and you don't need to increment it manually. So that is how a for loop works inside of R. So we can use for loops in vectors as well, but that will be a topic that will come later in this video. So after a for loop, we will now be discussing a while loop. So while loop. Now for a while loop, you need a condition, a looping condition, and the while loop will run as long as the condition is true. That is, while the condition is true. So let's say we have a variable called x and then we assign it a value of 1, right? Now we will define a while loop. While, a pair of parentheses, and let's define, or let's predefine the looping value or the looping body. So this is the body of the while loop, and inside this parentheses we will have to put the looping condition. Now let's say we want to run this loop as long as x's value is less than or equal to 5. So as long as x is less than or equal to 5, this, let's say we will print the value of x. Now you might notice that if we don't update the value of x, what it will run once, so it will print 1, and then it will check the condition once again. Is x less than or equal to 5? Well, x's value is 1, so of course x is less than or equal to 5. X is less than 5, that is 1 is less than 5. So since this condition is true, it will execute this code body once again. So in order to prevent infinite executions, you also need to keep one thing in mind when using a while loop. That is, you have to update the looping condition. So inside of our code body, we will update the value of x after each printing of x. So we'll increase the value of 1. So what will happen when we execute the while loop? So first of all, the value of x will be 1, right? So it will print 1, and then this statement will update the value of x. So the value of x will be 2, since x equals to x plus 1. So it will check the condition once again. Is x's value less than 5? Well, after our first loop, the x's value will be 2, which is less than 5. That is, x, which is 2, is less than 5. So the loop will run once again. So what will be the x's value at this point? It will be 2. And after that, it will print out 2. Once again, the value of x will update. And this will go on until x's value increases to 6. So since 6 is not less than or equal to 5, all of this will not execute since our condition is false. So let's execute this and see what it prints out. So like I said, it will be 1, 2, 3, 4, and 5. And as soon as we print 5, so at this low, so let's say the value of x is 5, right? So now 5 is equal to 5, so it will once again run this whole code body. So at this point, x's value is 5. Now after that, it will increase the value of x to 6, since we have increased the value of x after we print out 5. So after this point, it will increase the value of x to 6. Now once again, it will try to check the condition. Now since 6 is not less than nor equal to 5, it will skip this whole while loop entirely and then move out to rest of the code. So let's say if we write here print I am over, what will happen? So it will first of all execute all of this loop over and over again since this condition will be true for x's values up until 5, and then finally when this condition is false, it will move on to rest of the code. So once we are finished with the condition, it will print out I am over. And that is the basic gist of how a while loop works. Now, what would happen if we miss this increment condition? What would happen if we just print out the value of x? What would happen is it would keep on printing and printing the value of 1, and this loop will go on executing over and over again, since the condition is technically always true, and it might crash your browser as well. So always remember, when you use a while loop, you should put in an increment or a decrement condition which will take you out of that while loop. So in our case, what we did was we increased the value by 1. Oh, I'm sorry, this should be an arrow. So we increased the value of x by 1. So that was how a while loop works. Now after a while loop, what we will do is we will look at the repeat loop. Now the repeat loop is a bit different. It doesn't need any condition to run or a range of values to run. So what we saw with for loops is it needs a range of values, or later as we will look, or vectors, since for loops can be used for vectors as well, in order to run, right? And as for our while loops, it needs a condition to run, right? But for our repeat loop, it doesn't need any condition to run. So doesn't need anything to run. So for our repeat loops, how do you define a repeat loop? Let's first create a variable y and then assign it a value of 1. So after that, we will use a repeat keyword to initiate the repeat loop. And you might notice, since it doesn't need anything to run, it doesn't even have parentheses. We will just need a pair of curly braces, and then we will write anything that we want to repeat over and over again. So let's say I want to repeat the value of y. So we will print the value of y, and if we just leave it as it is, it will once again, okay, let me copy all of this. If we just repeat it as it is, okay, let's say we will increment the value of y as well. So it will go 1, 2, 3, 4, 5, 6, 7, 8. It will keep on going and on going. So if we leave it as it is, what we will do is run this, and then it will keep on going and going. Okay, I have to quickly reload this page because I don't want this website to crash. So what will happen is it will keep on going and going, and it will never stop, right? So in order to make it stop, we will need a break and continue statement like we discussed before. So as we increment the value of y to by 1 in each iteration, okay, this should be 1. And then after that, we will define a condition to stop this loop. So as we discussed before, there are two things that you can use to control a loop. First is the break statement, which stops the loop entirely, stops the loop. And then we have the continue statement. And then we have the next statement, which skips one iteration, which, okay, let's not say which, skips the current repetition or iteration. So in order to stop our repeat loop, let's say we want to stop our loop once y's value reaches 5. So we can define a condition by using the if statement. That is, if y's value goes greater than 5, that is, if y's value starts to reach 6, we will break this loop. So what will happen if we run this? It will print out 1, 2, 3, 4, 5. That is, once y's value reaches 5, so let's comment this, y's value reaches 5, it will try to update the value of y, and it will be successful. That is, y's value will be 6. And then after that, it will look at this condition, y's value is 6. So 6 is greater than 5. This is true, so it will break the loop entirely, and then it will get out of the loop. So let's observe that by typing print, and then print I am over once again. So it will print out 1, 2, 3, 4, 5. It will break out of the loop. So it will print out I am over only after the repeat loop has done finishing by this break statement right here. So let's say I print out inside of the loop, so print going on, right? Now when I click on run, you will notice that when the value of y is 1, and it'll increase the value of it'll print the value of 1 first, that is print the value of y first, then it'll increase the value, then it'll print on going on, and then increment to 2. So you can see that what is happening during each iteration. First it'll print the value of y, which in this case is 1, so 1 is printed, then the value of y is incremented to 2, then it'll check the condition, is y more than 5? Since 2 is not more than 5, it will not break our loop. It will go on to the next line. So it will print going on. And once again, our loop will repeat. It will print on 2. Since the y's value is 2 already, so it will print on 2. So it will print on 2. And then it will increment the value of y to 3. It will check the condition once again. Since this is false, it will not break. It will print going on once again. So that will repeat over and over till the value is 5. So like I explained before, once the value of y is 5, it will print 5, it will increment the value of y to 6, check the condition, since the condition is true, y is more than 5, it says 6 is more than 5, so it will break the loop, and then finally it will print I am over. So that is how the break statement works. So after all this, let's remove all of the code and then show how the next statement works. So I will show you a bit of code which will demonstrate the break once again and the next both in the same code block, that is our for loop. So let's say for I in a range of values from 1 to 10, we will want to first of all, let's say print I, but let's say we want to add a bit of condition checks first. Let's say we don't want to print the value of 4. So when we will do if i's value is equal to 4, we will use next, that is we will skip 4. So how next and break works is once the break statement or the next statement is executed, all of the code below this statement is ignored, like you saw with this going on. Once the value of y reached 6 in our previous example, it skipped the statement of print going on and ended the loop immediately. So that will happen. Once the value of I reaches 4, it will skip this print statement and move on to the next iteration. That is, it will update the value of I from 4 to 5. And let's say if I reaches the value of 8, we want to stop the loop. So we will do break. So this will stop the loop entirely. Forgive my spelling. So when we'll do run, you can see that it will print out 1, 2, 3. So after it is done printing on 3, what will happen? The value of I will move on from 3, I equals 3, to I equals 4. So it will move on from the value of 3 to 4. And it will check the condition. Is i's value equal to 4? Yes, since this is true, it will execute the next statement, which will skip all of this entirely and move on to the next iteration. So if you notice, this print 4 is not executed, hence 4 is not outputted inside of our output. So 4 is not printed. It is skipped to the next iteration. So i's value moves from 4 to 5. It will check the condition, this is false, so next will not execute, and I is not equal to 8 as well, it is equal to 5, so break will not execute as well, and it will print 5. So it goes on, and once i's value reaches 8, it will break the statement, so i's value, that is 8, is not printed out. So that is how next and break work inside of R, and I hope that is really clear to you guys. Now after this topic, we will look into how loops can work well with vectors inside of R. Now if you don't know what vectors are or how they work inside of R, you can check out episode 5 of our R Programming for Beginners series. It will teach you exactly that. So let's move on to the slides first, and then we will look inside of our code, that is our compiler. So loops are most useful when you are working with multiple values, right? And in R, those values are often stored inside vectors. So loops work well with vectors. A loop allows R to go through a vector one element at a time. So loops allow R to process each element of a vector, that is 1, 2, 3, 4, 5, each element individually, one value at a time. So they give you a chance to look at each value individually. This especially is helpful when different values need different decisions or actions. So if there are individual values of a vector and there is a loop, it will take those values individually and it will give individual output. Now in this case, we haven't done anything to the values, but inside of our example, we will. In the next example, we will see how a loop checks each number inside of a vector and responds differently depending upon its value. So let's head inside of our compiler now. So let's remove this and let's talk about loops with vectors. So for that, I'll create a vector with the combine function, and we will store a value. Okay, for those of you who don't know what a vector is basically a collection of values. So a vector in our case will be 2, 5, 8, 11, and let's say 14. So this is a collection of values, and we combine this collection into a vector using the combine function, that is C. So numbers stores a vector, or let's say numbers is a vector of these numbers right here. Now we will loop through these numbers individually using a for loop. So for n, so this is a looping variable, and we define this to store the individual value of a vector during each repetition. So during our first repetition, the value of 2 will be stored inside n. Inside of our next repetition, the value of 5 will be stored, and next 8, 11, and then finally 14. So for n, or let's say to make it easier, for value in numbers, so an individual value, or let's say an individual number inside of vectors, we will output a different output depending upon the value of each number. So if our number is greater than 10, we will use something called paste. Now paste is a function in R which sticks words or numbers together into one sentence so that you can print them neatly in a single line. So in our case, we will do paste, and then we want to paste our number first. So number, and then we want to print is large, since this number is greater than 10. Or else, if the number is not greater than 10, we want to print our combination, that is paste, number, and then is small. So what are we doing inside of this for loop? First of all, we are looping through the vector, and during each iteration, so during the first repetition or iteration, so let's say repetition or iteration 1, the number is equal to 2, since that is the first value inside of our vector. So it will check, first of all, it will store 2 inside of this number value, and then it will check if 2 is greater than 10. Since it is not greater than 10, it will output this value. And then inside of our second iteration, so let's say iteration 2, the value of number will update to the next value. So after 2, we have the value of 5 inside of our vector. So the value of number will store 5. It will compare 5 greater than 10 or not, and then if it is greater than 10, it will execute this, and since 5 is not greater than 10, it will execute this line once again, and once again this process will repeat. The number value will store the next value, that is 8, compare, then again the value will update to the next value, so number will store 11, again this loop will execute, and it will come to 14, and after all of the values are iterated, or let's say the number value has stored the value of all of these values individually, that is 2, first of all 2, and then 5, 8, 11, 14, the loop will finally be over, since it has iterated through all of these elements of the vector, and then our program will stop. So it will say 2 is small, since first of all the value will be 2, it will update to 5, it will compare this comparison, and it will print 5 is small, and again with each element. Okay, I know I repeated the same points again and again, but I hope that you understood how loops work with vectors. So this is a basic idea of it. And now that we understand about this as well, let's finally head over to our summary slide. So that was it for this video. And as a recap of today's topics, these are the concepts that you learned today. We learned what a for and while and repeat loops are. There's for loop loops through a fixed range of values or vectors, and it is repeated fixed number of times. Whereas the while loop repeats while a condition stays true. And finally, the repeat loop runs infinitely until we use the break statement. And then talking about break and next, we also learned that break statement breaks, or let's say stops, the loop entirely, whereas next skips the current iteration and then moves on to the next repetition. And finally, we also learned how the for loop can be used with vectors to loop through individual vector values beautifully. So that was it for today's video. In the next video, we will be discussing and working with functions inside of R, which are a good way of reusing code. So I hope you don't forget to tune in for that. If you like this video or found this video helpful in any way at all, please drop a like and subscribe to our channel for more such videos. And until the next time, bye bye and happy coding. Hey everyone, and welcome back to the R Programming for Beginners series. Now in the last episode, we talked about loops inside of R, and today we take another step towards our learning journey by learning about functions in R. This episode is going to be a complete discussion on functions. So first we are going to learn the theory about functions and then move on towards the practical coding demo. So before we write any serious programs, let's understand functions. So what is a function? A function is a reusable block of code that performs a specific task. Instead of writing the same code again and again, we write it once and we call it whenever we want by passing inputs into it, and then we get the output. So that is what a function is. So why do we even need to use functions? Functions are extremely useful, and not just inside of R, but any other programming language as well. Functions help us to write clean code, reuse code, and also organize the code that we write. They make programs easier to read, easier to debug, and easier to maintain as well. So now that we know about why we use functions, let's get to know the basic structure of a function inside of R. Now inside of R, functions are created using the function keyword. So in order to create a function, you have to first write the function name and then assign it a function body with the help of the arrow operator. After using the arrow operator, you use the function keyword to let R know that this variable right here is going to be a function. And after you use the function keyword, you have to write what you want to pass inside of the function. That is our input values, which are called parameters. And then you open a pair of curly braces and write the function body, which is the code that will run when the function is called. So that is how you define a function inside of R. Now let's talk about the function arguments. That is the values that you pass when calling a function. So as I just stated, arguments are the values that we pass into a function when we call them. So arguments allow us to work with different data. Now don't get confused. When we define a function, the inputs that we write inside of the function brackets are called parameters, as we just discussed. But when we call or use the function, the actual values that we pass into it are called arguments. So in this case, our sum is a function and a and b are arguments, since we pass these values inside of the function when we call it. So in simple words, parameters and arguments refer to the same inputs but at different stages. Parameters are the placeholders used while defining a function, whereas arguments like these, are the real values that we pass into a function when we call it. So we are passing the inputs of 5 and 3, and our sum function will give us an output of 8 because it is a sum of a and b, which in this case have a value of 5 and 3. So once again, arguments are the real values that will be passed into a function when calling it. Here we call the sum function and pass in our arguments, which are a and b, and they allow the function to work with different data each time that it is called. As you might also see here, a function usually returns a result. Here we call the sum function, and it returned us a result of the sum of the arguments a and b. So in R, a function returns values. We can explicitly return a value using the return statement. So a function will return a value, or let's say a result, when we use this return statement. But there's also a shortcut that we will see soon. So for now, the thing that you need to keep in mind is that a function takes input, it processes the input, and it returns the value with the return statement. Okay, now that we have some basic knowledge about functions, let's take a look at them practically inside of the R compiler. Okay, now that we are inside of the R compiler, let's define our first function. Now for a function, first we have to define a function name. So let's say our function will be called add and then numbers. So add numbers will be our function, and the name itself is quite explanatory. It will be a function to add numbers. So in order to declare this variable as a function, first we will use an add operator and then use the function keyword to take in the parameters. So the parameters are the values that a function will take inside of it to process and give us an output. So let's say it will take two numbers, a and b, and these numbers will be returned as their sum. So a plus b. So this is how you define a function. We created a function called add numbers, which takes two arguments a and b and returns their sum, even without the return statement. So we did define a function, and we defined what it takes as inputs and what it gives as output. But we have to actually call the function in order to use it. So in order to call a function, we just write the function's names, so add numbers, and then we pass in the necessary values that have been defined. So in our case, we have to pass in two numbers that we want to obtain the sum of. So inside this, let's send 5 and then 3. Now after this, we will run our program to see that 8 is being returned. So since we are passing 5 and 3, it will return 5 plus 3, which is 8. So that is how functions work. In this case, these are the parameters, because while defining the function, we have passed in the values of a and b. So these are the parameters, and these are the arguments, which are the values that we pass inside a function when we call it. So this is calling a function, and this is defining a function. Now let's do the same thing with a return statement. So first we will create another function. Let's say a function to multiply numbers. And then after that we will define the function. So multiply underscore numbers, and then assign it a function keyword which takes in two inputs, let's say x and y, and it will return the product of those. So we'll use the return statement and then use x times y. So this will return x times y. So let's try to call our function right over here. So multiply numbers. Let's say we want to multiply two numbers, 3 and 4. So we will first of all run this program. We should first get 8 and then 12, because 3 times 4 is 12. Now the one thing with using return and not using return is that when you don't use return, only the last statement inside of our code block is returned. So let's say we had here a minus b, right? So when we do 5 and 3, only the last statement will be returned. So this will be returned. So when we run this, you can see that we are given a value of 2, which is the value of a minus b. So if we want to explicitly return some specific value, we want to use the return keyword. And the thing about return is, after a return is used, none of the code that is below this return function is executed. So let's say we want to print I am being printed, right? And so this will, since we have used the return statement above this line, this will in fact not be executed. So if we do run, we can see that only a plus b is returned and the print statement is not executed. Whereas if we don't do return, so let's say we just do a plus b, right? So a plus b, we run this, you'll see that I am being printed is being executed because this is not below a return statement. So the thing you have to note is that if you don't want to use return, you're completely fine by just giving out the last line of your code block. So a plus b, this will actually be a return value since it is the last expression that is inside of our code block of our function. So still a plus b, that is the value of 8, is being returned. But if you want to explicitly return something and not execute anything below our required line, you have to use the return statement. Using the return statement allows us to exit a function early, which can be conditional as well. Okay, now that we know about the basics of a function, let's get to learn some extra topics as well, shall we? Now the thing that we are going to talk about are default parameters. That is, when you don't pass in arguments when you call a function, you can make it so that the function uses a default value instead of the value that you input. So if we have a bit of code, you can see that here we have defined a function called power, which has x as a parameter and y equals 2 as a default parameter. Now what does that mean? That is, this means that you can just pass the value of x, you can also pass the value of y, but if you don't pass in the value of the second parameter, that is, you only pass one value, it will use y's value as 2 as the default value. So when you just pass in 4, it will take on the value of x and it will be 4 to the power of 2 since y's default value is 2, and it will return to 16. So we'll test this out as well, but before we test that out, we want you to know about scope as well. So what is scope? The scope of a variable defines the part of code where the variable can be accessed or modified. So there is the global environment and there is the function execution environment inside of R. The variables that are inside of the functions are not accessible outside. That is, they are not accessible in the global environment, and we'll be looking at that through a bit of code. First, we'll look at default parameters, and then we'll be taking a step toward understanding scope of variables. So we are back again at our compiler. First, we will be talking about default parameters. So default parameters. So let's define a function which is called power, and then we'll give an arrow symbol to assign it a function value using the function keyword, and then we will use the parameters to be base and exponent, but our exponent's default value will be 2. So it will return base to the power of our exponent, so exponent. And once again, because this is the last evaluated expression of our function, it will be returned automatically without the need for using a return statement. So now that we have defined the function with a default parameter, that is exponent equals to 2, let's try and call the function. Let's first try to use it normally. So we'll call the power function. Let's say we want to do 3 to the power of 3 itself. So in this case, we are providing arguments for both the base parameter, that is 3, and the exponent parameter, that is 3 again. So when we will run this, it will return us a value of 27 because the base's value is 3 and the exponent's value is 3 as well. So 3 to the power of 3 is 27. But what would happen if we forget, or let's say if we don't include the exponent argument intentionally? What would happen is the base parameter would have a value of 3 since we have passed an argument of 3, but the exponent's value would be 2 by default. So it will be 3 to the power of 2 and it will return us 9. So that is how default parameters work. If you mention both of the parameters when calling the function, it's all good. The function performs as intended, but if we miss a parameter, it will take on a default value. So that is how default parameter functions work. Now let's understand the scope of a variable. So we'll be moving towards a new topic called variable scope. And then inside of the variable scope, what we will do is first we will define a variable x which will have a value of 10, and then we will have a function called test scope since we want to make this function to test our scope, and it will contain a function which will have a variable defined once again, and that variable will be 5. So let's say we will return the value of 5 once again. It should, when we call this function, it would just give us 5. So first of all, let's call our function test scope. Now notice that we have defined the value of x to be 10. Now inside of our function we have defined the value of x to be 5. Which one would be returned? Let's see. So you can see that the value that we define inside of our function is returned inside our output. But what if we do x outside of our function? So let's say print x. What do you think will happen? Well, let's see. So we can see that inside of our function, the value of x is 5. But outside, when we try to access that value of x, it will give us 10. Since this is a variable of the global scope, that is the global environment, but this is the variable of a function scope. So let's say we want to define this variable as y, and we'll print out y. And let's say outside the function, we will try to access the value of y. Let's see what will happen. So when we run this, you can see that it gives us an error. First, it will output the value of y. Since we have been using this inside of the function, we have defined y inside of the function and used y inside of the function. So at first, it will give us a return value, but when we try to access this variable outside of the function, that is outside in the global environment, it will give us an error. It will tell us that object y is not found. Since we have defined this inside of a function, it is not accessible outside of the function. So I hope that is clear for you guys. And now that we are done learning about functions inside of R, let's move to a quick recap slide. So let's have a recap of today's topics. Today we learned that functions inside of R are defined using the function keyword. And next we learned about arguments, which are input values that are passed into the function for processing. We learned about default parameters or default arguments, which are preset values used when the user doesn't provide input. We learned about the return statement, which explicitly sends back a result, and we learned that it is optional as well, since the last evaluated expression inside of a function gets returned automatically, and which is this automatic return, the thing that I just said. Next up, we also learned about the scope of a variable, that is where the variable can be accessed or modified. Variables inside of a function stay local. They can't be accessed outside of a function, which is the global environment. We also learned about reusability, which is if we write a function once, we can reuse it multiple times to avoid repetition. And finally, we learned that functions help us to write cleaner code, which makes programs easier to debug, maintain, and scale. And that was it for this video. Thank you for watching. On the next episode, that is episode 13, we'll be talking about working with R packages, so don't forget to tune in for that. If you liked this video or found this video helpful, make sure you drop a like and subscribe to our channel for more such videos. And until the next episode, bye bye and happy coding. Hey everyone, welcome back to another episode of the R Programming for Beginners series. Now in the previous episode, we learned about functions, how R uses functions to perform tasks and make our work easier. And in this episode, we're taking the next step and learning about R packages. R packages are what allow R to grow beyond its basic features and become a powerful tool for data analysis, statistics, and data science. And don't worry, we won't be using real datasets just yet. Right now, the goal is to understand what packages are, why they exist, and how they fit into the R ecosystem. Once you understand this concept, working with packages later will feel much more intuitive. So first of all, let's start by answering a simple question. What are packages inside of R? R is powerful even on its own, but its real strength comes from packages. A package is a collection of ready-made functions, datasets, and help files that are designed to solve specific types of problems. Instead of writing everything from scratch, packages let us use tools that have already been carefully built and tested by experts and the R community. And some packages are stats, ggplot2, dplyr, and tidyr. And you can think of R as a basic toolbox and packages as specialized toolkits that we add when we need them. So base R plus packages equals superpowers for data science. That is, when we add packages inside of already base R, we get incredibly useful tools for data science. Now that we know what packages are inside of R, let's talk about why we need them. So why do we need packages? Well, packages save us from reinventing the wheel. Many common tasks such as performing statistical analysis, building machine learning models, visualizing data, etc. have been already solved. Instead of spending time writing complex code, we install packages created by researchers, statisticians, and data scientists from around the world. This helps us increase productivity and automate our workflows. This is one of the biggest reasons why R is so popular inside data science and research. And now that we know why we need packages inside of R, let's talk about base R, that is basic R without any packages, versus external packages. Some functions come built directly into R. This is called base R, and it includes essential tools like basic math, simple plots, and summary statistics. So mean, sum, and the basic plot function in order to see plots. This is basic R. However, many advanced features do not come pre-installed. These features are provided through external packages, which we install only when we need them. And now this design keeps R lightweight and flexible. Some of the functions that are associated with packages are ggplot, filter, and mutate. We install packages only when we need them, and this design keeps R lightweight and flexible. So when you add packages to base R, it gives you more power for data science. Now let's talk about installing packages. So before we can actually use a package, we must install it. And installing a package means downloading it from CRAN, the Comprehensive R Archive Network, and storing it on your computer. So in order to actually install a package, we will have to open our R environment and run the install.packages command, and it installs the packages on your computer. The actual command is install.packages, and inside of the parentheses, the name of the package that you want to install inside of quotes, and it will install the package on your PC or on your device. And this step is usually only done once unless you remove R or want to update the package later. So it is a one-time process. Now only installing a package isn't enough to use it. Each time you start a new R session, you must tell R which packages you want to use. So therefore we have to load packages inside of R. So after we install an R package, we tell R what package we want to use by actually loading the package into our memory. And once loaded, all of the package's functions become available for that session. So we can use the package successfully. So to load a package in R, we use the library function. So it's library, and inside the parentheses, the name of the package that you want to use. So if we wanted to use a package called ggplot2 that we just installed inside of our R session, we would have to type out the library function, and then inside of the parentheses of the library function, we would have to write the package name. So ggplot2 inside of this parentheses. And like I said, once loaded, all of the package's functions become available for that R session. Now, you know how to install packages and you know how to load and use packages as well. But what about searching for the right packages? R has thousands of packages and new ones are added all the time. Knowing how to search for packages is an important skill. We can search for R packages and functions directly inside R, or explore them online using the CRAN website. As you gain experience by installing packages, you will learn what packages are commonly used for different tasks. So you will install packages, use them, and gain experience, and then eventually you will naturally learn which packages are commonly used for different tasks. So inside of R, help.search or question mark keyword are used to search through all documentation and install packages to find the functions related to a specific keyword that you want to search. And now that you know about searching packages, let's talk about updating packages inside of R. Packages are updated regularly to improve performance and add new features. Keeping packages up to date helps us to avoid errors and ensures compatibility with newer versions of R. So, updating packages is a simple maintenance task that becomes a part of good R practice. And inside of R, you update packages by using the update.packages command. And that was it for this video. We learned that packages are what turn R into a complete data science ecosystem. And while we only learned the theoretical knowledge behind packages inside of R, we will for sure make use of this information in further videos. In this beginner series, our goal is to understand what packages are and why they matter. And like I said, in future R courses, we'll actively work with popular packages to analyze data, create visualizations, and build models as well. For now, we have to focus on the concepts. Once you understand packages, using them will feel natural and intuitive. And that was it for this video. In the next episode, we're going to be discussing about basic input and output inside of R. So we hope you stay tuned for episode 14. And until then, bye bye and happy coding. Hey guys, and welcome back to another episode of the R Programming for Beginners series. Now, in the last episode, we learned the theory behind R packages, what they are, why they exist, and how they help extend R's functionality. But once we start using R for real tasks, we don't just work with code in isolation. Our programs need to read data from the outside world and save results back to it. And that's exactly what we will learn in this episode. Basic input and output in R. Now let's start by understanding what input and output actually mean. So, what is input and output? Now, programs don't live in isolation, like I said before. They need to read input and produce output by processing that data. And that is exactly what our R program does as well. Our program needs to read input and produce an output. So, input is any data coming into a program, from files, the keyboard, or other programs as well. And output is the information that the program sends out after processing. That is the basic definition of input and output. Now let's talk about file input and output. So what is file I/O, that is input and output, in R? File input and output means reading data from files and writing results back to files. In this episode, we'll keep things very simple. We'll be working only with plain text files in order to demonstrate what is input and output inside R, because they are easy to understand and help us focus on the basics of file handling. Now let's talk about reading from text files. R can read text files line by line, and each line in the file becomes one element inside of a character vector. And if you are new to this series or don't know what vectors are, we have covered everything about vectors inside of R on episode 5 of our R Programming for Beginners series, so I recommend you check that out to know more about vectors. Well, for this episode, you just need to understand that vectors are an ordered collection of data elements which are similar. Well, for this episode, you just need to understand that vectors are a one-dimensional data structure which is used to store an ordered collection of similar items. That is, all of the elements inside of a vector are of the same data type. So inside of this character vector, all of the vectors are character data types. That is line 1, line 2, and line 3. All of these are strings, and this vector is a collection of these strings. So, like I said, when we read from a file, each line inside of the text file becomes an element inside of a character vector. That is, the first line becomes a single element, the second line becomes another element, and the third line becomes another element as well. And in order for R to read this text file must already exist in your working directory. And we will talk about how you can know your working directory later on in the video. Okay, now that you know the logic behind reading files inside of R, let's talk about writing text output onto files. Now, R can also write text into files, and this is useful for saving results, logs, or simple reports. So, if you have a character vector from our previous line, suppose this is our collection of lines. Suppose the first line says hello world, second line says welcome to R programming, and the last line says bye bye. So this is a collection of our characters, or let's say strings. This is a character vector. While writing text into files, R writes those character vectors into the text file line by line. Now, if we have a character vector like we did in the previous slide, like this, it is a collection of strings. If we have a character vector while writing an output, it can write the individual elements of that character vector onto a file and save that output. And by default, writing into a file will overwrite existing content unless told otherwise. That is, each time you save to a file, it will override whatever is already present inside that file unless we specify that we don't want that and instead we want to append content into the file. Append just means adding content onto the file at the bottom. So now that we have talked about the basic logic about reading and writing, let's see the important functions for text input and output inside of R. So these are the functions that we'll be using. So in order to read text data from a file, we use a function called readLines, and this will read each line of that text file and return those lines onto a character vector like we discussed before. Next up, in order to actually write content onto a file, we have two functions. First is the write function, and this is used to write data in a simple space-separated format onto a file. And this is typically used for numerical data, whereas the write lines is used to write character data line by line. And this function, that is write lines, can only be used to write character data and not numerical data. So do keep that in mind. And don't worry if you don't understand what these functions do just by reading this table or hearing it from me. We will try all of these functions one by one later on inside of our practical demonstration, which we will be doing inside of our studio. So do stay tuned for that. But before we do that, let's talk about knowing our current working directory, that is files and working directory. Now, R looks for files inside of its working directory. That is, if you just mention the name of the file, it will always look inside of the working directory and not other folders. If you want to access file from other folders, you have to provide its full path, and those files should be accessible. That is, R should have the permission to access them in the first place. But by default, like I said, every R session works inside of a specific folder called the working directory, and this is the default location where R looks for files when reading data and where it saves files when writing our output when we don't provide a specific path. And we can check the current working directory using a function called get working directory, and we can change it, that is, we can change our current working directory by using the function set working directory. And do keep in mind, like I said before, if a file isn't in the working directory, you must provide its full path in order to access it. Okay, now that we have these things out of the way, let's get into our practical coding demonstration, shall we? And okay guys, now we are inside of our studio, as you can see, and right now I'm inside our console and I have not created any file. So first, let's start from checking our working directory. Like I mentioned before, when you mention the file name to R, it first checks the working directory. So in order to know what directory you are working inside of, you can just type out the command get wd, that is working directory, inside of your R console, and you can just hit enter and it will give you the path of your working directory. So right now I'm inside users and then rivas and then documents. So inside this I am working with R. So when I create a new file, it will be created inside this directory, and any file we read or write without specifying a path will be searched for here. So let's first of all create a new file to start working with reading files. So our file will be an R script, of course, and let's save this as input and output. Okay, so we'll go inside documents first. As you can see, this is the same path that we got when we typed out get working directory inside of our console, and here we'll create a text file in order to work with. So let's say we create a new text document and its name will be let's say example.txt. So this is example.txt, and inside example we'll write a bunch of lines so that we can read from it. So let's say first it's welcome to the R programming for beginners series, and then let's read from files now, shall we? Let's save this and then try to access it from inside of our R script, that is input and output, which I have opened inside of our R studio. I hope this is visible to you guys. We'll start to read lines from our files with the help of the function read lines. So first we'll create a variable called text data, and inside this text data we'll give an arrow operator, which is alt and then the hyphen symbol. It will give you an arrow, or you can just physically type out an arrow like this, less than symbol and a hyphen. So after that we will use the function read lines, and then we will specify what file we want to read our lines from. So it is, in our case, it is example.txt, and then after that we will want to print out that text data. So we'll print out whatever lines we read from that file. So this is it. I'll select this and I'll click on Control and Enter, and it will create a character vector, as you can see. So whatever we typed inside of, so it gives you a warning that incomplete file line found on example.txt, because every file should end on a new line character, and in our case we haven't defined that inside of our file, but this doesn't matter right now. So you can see that when we print out text data, it gives you a vector. You can see by this indexing 1, 2, and 3. The first line is welcome to the R programming for beginners series. The second line is let's read from the files now. And the third line is shall we. And all of these lines are stored inside of a character vector, as you can see, CHR character vector. And it has index from 1 to 3. And each line is a starting element. So the starting line is the starting element, that is the first element, the second line is the second element, and the third line is the third element. And this is how you start reading from files. If we were to edit that file, so let's say we open this and we add a new line. So let's say this is going to be the fourth element, right? And let's end this in a new line and then save. And then we'll once again execute our R script. So we'll select all of this, or you can just click on run, but I'll select all of this and then hit Control Enter. Now you can see that our text data holds character elements from 1 to 4. That is, it holds 4 lines now. First, second, third, and then our newest line, this is going to be the fourth element, and as we predicted, this is the fourth element of our character vector, which once again is just a collection of strings in this case. So this is for reading all of the lines that you have inside example.txt, and once again, this is inside of our current working directory, and that is why R is able to access it. If this was not inside of our working directory, we would have to provide the full path, including the disk and then all of the folders which lead up to example.txt. But since this is inside of our working directory, our current working directory, we can access it just by writing its name. So I hope that is clear to you guys. Now, this was the method to read all of the lines inside of a text file. But what would you do if you only wanted to read a few lines? Well, for that, you would have to mention the number of lines. After you mention your file, you can write n equals, and this is the number of lines you want to read from that file. So let's say I just want to read 2 lines from our file right here. So you can define the number of lines you want to read by separating it with a comma value, and then n equals 2, and then we can run this file once again. Now, text data will store only 2 lines, and let's output this onto here. So you can see when I click on this line and hit Control Enter, that is executing this line right here, we can see that text data only holds 2 lines, the first 2 lines, which is welcome to R programming, and let's read from files now. So in here, inside of our environment as well, you can see that text data holds a character vector of 1, 2, so only 2 elements. Welcome to R programming, and then let's read from files now. So this is what you do when you want to read only a few select number of lines. Now we are done with reading lines from files. We have read all of the lines, and we have read a few lines as well. Now what would you do if you want to write things onto our file? So let's get on with that, shall we? So in order to write into files, you have 2 methods. One is just plain write. Okay, I think I have cap. Okay, write. And then the next is write lines, right? So these are the 2 methods, and I'll tell you the difference between these 2 methods by practically demonstrating it. So first, let's use the first method. For that, we'll create a numbers vector which will store values of, so this is how you define a vector inside of R. You use the combine function, that is C, and inside of the parentheses you define the values that you want the vector to contain. So let's say I want this vector to have 10, 20, 30, and 40. Now in order to write this vector onto our lines, and remember you can only write vectors into lines. Okay, so we have defined our numbers vector, and let's say we want to write these values into a file. For that, you will have to use the write function, and inside of the write function you'll have to mention 2 parameters. One is the vector that you want to write into the file. In this case, we are going to write the contents of the numbers vector, so we mention our numbers vector, and then after that the name of the file that you want to write into. So in our case, let's say we want to write our data into a file called numbers.txt. Now if this file already exists inside of your working directory, that's nice, but even if it doesn't exist, R will create the file for you and write into that file. So we mention numbers.txt, and then we select all of this, and then we hit enter. So when we check our directory, we can see that numbers.txt has already been created, and inside numbers.txt we can see that our vector content, that is 10, 20, 30, and 40 have been written. So this is how you write into files, and you might notice that these are separated by spaces. So that is what happens when you use the write function. It is typically used for numerical values, and when you write numerical values into a file, the default result is that those numerical values are separated by spaces. But if you want to set a separate separator, Wow, that's a tongue twister. If you want to separate a separate separator, and even set the separator. So you can do that by mentioning here, comma, sep equals, and then the separator. So let's say I want to separate the values by comma, and I save this, and I select all of this, and I hit Control Enter. So that is executing the files. Now, when I check my numbers.txt, okay, let's close this, and then open our numbers.txt once again, you can see that they have been separated by our mentioned separator, which in our case is a comma. So when we open our script once again, let's try to separate those by the pipe operator. So this. So let's save it and then hit Control Enter. Now, when we open numbers.txt, we can see that they have been separated by our pipe operator. So that is how you separate values that are written into a file by the write function. And I hope that is clear to you guys. Now, next up, let's talk about the write lines function. Now, while the write function is commonly used for numeric data or quick exports, the write lines function is typically used for character data, and you can only write character data into a file if you use write lines. With the write function, you can write both the number data and character data as well, but with write lines, you can only write character data. So let's remove this first, and let me mention that when you use write lines, this writes each element as a separate line in a text file, making it ideal for readable text output. So let's say we have a new vector called lines. Okay, let me disable the caps lock. And then let's say we have a new vector called lines, which has elements, first of all, R programming. And then another element is basic input and output. And then our final element will be learning file handling. Okay. And then after that, we will use the write lines function. So write lines, and then the lines you want to write, that is the vector which contains the lines you want to write, and then the text file which we want to write into. So in our case, let's say it's output.txt. So when we select all of this and hit Control Enter, we can see when we open our directory that output.txt has been created as well. So from this, you can know that both write and write lines create the text file for you if this doesn't exist. And this is created inside of your working directory, right? Now, when we open output.txt, we can see that all of the lines have been written in separate lines. So this is the first element of our vector, which is lines. So this is the first element which appears as the first line, and likewise with the second and third element. They also appear as the second and third lines. So this is how write lines work. Now let's talk about another thing that you might want to know. Suppose we change the content of the file. So let's say this will say this has been changed, and let's say this says this has been changed too. Now first of all, let's close this. Now keep in mind that output.txt already exists inside of our working directory, right? When we mention new lines, that is when we change the character vector and then we try to write this content into the file that already has existing content. So for now, our output.txt contains our previous content, that is R programming, basic input and output, and learning file handling. But when we try to change the content and then write into the file once again, so let's select all of this and hit Control Enter. When we look at that file, you can see that the previous content has been overwritten. That is, it has been removed and replaced with the new content. This is the default behavior that both write and write lines have. But if you want to add content into a file, you will have to do things a bit differently. So let's say we want to add content instead of just replacing it. So for that, we will have to use write lines. So let's say we want to add a line called new line added, right? And then we want to write it into output.txt. So if we want to add this line onto output.txt, okay, first let's see what happens if we do it as it is. So write lines, new line added. Now remember, we want to add this line and not replace things, right? But when we execute this and open output.txt, you can see that all of the lines have been removed and only this line is added. that is it. That is, the previous contents of this output.txt are overwritten. So when you want to actually append content onto a file and not just rewrite it, you will have to use a function called cat, and you'll have to mention the file name, file equals, and then you will have to add a parameter called append equals true. And when you've done all of this and hit Control Enter, and then you check the file, output file, you can see that the new line has been appended and not just rewritten. So that is how you append content onto your file. And that is it for this video. Now we'll be heading over to our quick recap slide. Quick recap, we learned all of these topics today. We learned what input and output are, and what read lines, write, and write lines do inside of R, and what a working directory is as well. And that is it for this video. Thank you for watching this, and please do leave a like and subscribe to our channel if you found this video helpful and want to stay notified about further videos.